The question I want to answer in this one is, how do we actually ask Django, our database inside of Django, and all of the data that's in it, how can we ask it questions? Questions like you might with ChatGPT or Claude. How do we go about doing that? That's what we're going to do in this series. Now, what it starts with is having a database that allows for us to store actual vectors. That is NumPy arrays, or basically a bunch of numbers in a column itself. So we can actually use it to actually handle all of the queries we might need to do. Now, there's a lot more to it than just that, but that's the idea, is we need a database that actually works with that. So for that reason, I partnered up with Neon on this series because they have Pgvector support out of the box. So we can just use Neon as both our Django database, but also as our vector database. These things can be mixed and matched, and you can use all sorts of stuff, as we'll see. But the general idea here is, in order for us to be able to use natural language for our queries, we need to turn that natural language into number representations. And so when we actually do that, and then we need all of our content to also be numeric or number representations as well. These are called embeddings. And so what we end up doing is we start off with just semantic search, just doing embedding searches, essentially saying like, hey, fill in the blank, and then it'll do a quick search for your entire blog post database, and then we'll find it. Or the dog jumped over the cow. We'll actually take a look at that example where you actually do a search into your database for just that data. Then we start to add it more and more advanced, so we can actually see how to do not only semantic search or semantic querying, but also we can take text to SQL semantic querying, as in, what are my most popular blog posts from today? This would actually require some structured data to actually look in your database to find a SQL query to aggregate your data, to see all of the page views for the day and combine it with all of the blog posts that are available, and then return that data back, and then infer that data, and then give you a response like, hey, your top blog posts were this, and this is how many views they had. All of that is done with an LLM and embeddings. LLMs as in something like ChatGPT or GPT-3 or GPT-4 or all of the new ones that are coming out down the line. So there's a lot to this, but I think it's a very compelling reason to use Django. For one, Django has a lot of these things that now have support to do this almost out of the box. Not quite there, but there are some good packages out there like Pgvector that make it a lot easier to make all of this happen. And then, of course, having a robust production-grade database that makes all this work is also critically important to actually use this in your projects. Now, the key thing here is to help you draw insights from your data. So you can actually just ask it queries that you might want to ask someone who's an expert in your data, right? What are those things that you're going to ask it? Well, that's something you're going to need to explore on your own. But the idea here is building the infrastructure and the tools to make all this happen. Let's take a look at a demo as to the final result of this series so you can actually get a better sense as to what you're getting yourself into other than what we just talked about. Let's take a look. Let me show you a demo of what it is we're going to be building in this one. Now, of course, this is the result of the whole series, so there's a lot of things that I'm just not going to discuss right now because, well, it's discussed in the series. But the idea is this: we talk to our Django database, as in I can do a query like, what is an org? This is not doing a search. It's not a standard database search. It's a more robust one. But if I go ahead and do that, I do what is an org, it's going to go ahead and do a quick search for me, and then it gives me some results based off of my actual blog post. How about we say what is an org and its keywords and do a search like that. Now, once again, what it's doing is it's actually looking into our blog posts and it's looking for what's most relevant in here, and then it's giving a response. It's going to interpret that response for what's most relevant. Now, doing semantic search like this is actually really cool. It makes our search engine much better. It's a lot more powerful in terms of what we might want to find with any given blog post. So like if you wanted to find something like, what do you make? Then your semantic search will help you be able to do that. And this is essentially what's happening here. It's not quite the same, but it's essentially what's happening here because it does eventually interpret the results that happen from a semantic search. So really, we are doing questions to our database right here. But what if we wanted to have more advanced questions, more robust questions? Things like, hey, I said are the top 5 blog posts in here. I didn't even say the right question. What keywords do their content have? What it does is it infers this as a SQL query, as in it's going to go into our database. It's going to actually look at our blog posts and our analytics page view, as in 2 different tables that are connected, but it does look for them, and it does this automatically. I don't actually have to tell it anything other than the tables to look in, and then it does a query. It combines those queries to find your top responses for this. And so what we get for our top responses are this. Title, taking it very seriously. Okay, so you might think, oh, it's just making this stuff up. It's hallucinating. But if I search taking it very seriously, here's the title, and here is that blog post. Today, April 1st, blah, blah, blah. If we look in here, April 1st, keyword, greeting, happy, internet, apocalypse, pretend. I think those are relatively good keywords based off of what's in here. Now, we could make this better in the sense that we could extract the keywords prior to doing this search and having a full-on field for those keywords, and in which case this response would be even better. But overall, the idea here is we're able to do these fairly vague, generic responses from natural language. Like, I just made this up on the spot when I actually did it. But you could also see something like this. What are the top 5 least viewed blog posts from today? And then you could be able to respond with that value and that data. And it's pretty cool. So it shows us the SQL query that's happening, and then it does all this stuff. Now, what if I did from 2023, last year? Right? Dating this, this video. But the idea being is it now goes, hey, the timestamp between 2023 and 2024, it says there's nothing. So that is generic. I didn't write all of those things out. But if I change it to 2024, that's where all the analytics are, because that's where I faked all the data. I can now see that it's going to give me maybe some sort of response in here. And now it's saying there's no blog post, which is peculiar. But it says exact year in the year 2024 to 2025. Let's try this one. Maybe that's going to be a little bit better in terms of how this ends up working, because the blog posts themselves are from the actual year of 2020. So if you actually look at any blog post that says 2020, but the analytics page views, those are from literally today and yesterday, right? So they're not actually very accurate representations of real data, which is why this query is still kind of funny. But overall, what we see now is once I did a little bit different of a query itself, it does give me the actual responses, which were identical to what we just saw when I said from today. The point here is that we can do these powerful requests here. Now, of course, there's always some concern that you might want to have or you should have when it comes to actually doing raw SQL queries automatically within a AI system of some kind. That is definitely something that you should be aware of. The nice thing about all of this is it's not something I cover at this point, but Neon has the ability to do branching, that you could just branch and then do the queries on those branches. That I think is actually something really compelling that you might want to do after you finish this series. But that's the demo. Granted, we go in through a lot of other stuff in here as well, and I also hopefully help you connect the dots as to what's actually happening under the hood with semantic queries, like just writing out natural language and querying that into your database, because that alone will make your database searches that much better. You don't even need to interpret the results. You don't need to do any of that. You can just do semantic queries, and I think you get a lot out of this series itself and learning how to do that with embeddings and turning queries or like user searches into embeddings as well. So yeah, that's the demo. There's a lot to talk about. Let's go ahead and take a look at how this is done. Let's talk about what you need to know to do well in this series. First and foremost, this is a Python heavy series, so knowing things about Python and having Python installed are required. Now, if you don't know that much about Python or don't have it installed yet, check out my series called 30 Days of Python. You'll install Python there. You'll learn some of the basics. You'll learn how to do lists and class and iteration and loops and string substitution. Even stopping at day 15, you'd probably be enough to actually do well in this series. After you go through that one, you're going to want to have Python 3.11 installed. That's what we're going to be using for this series. The installation process is very straightforward, but the idea is 3.11 supports all of the packages we'll be using in this series. 3.12 might support them by the time you're watching this, but from my test, only 3.11 ended up working. Now, we will be using Django, but only a little bit in as it pertains to Jupyter and really storing data and extracting data. It's not really Django heavy other than the models, but we'll talk about those things when they happen. If you want to learn more about Django, check out cfe.sh/YouTube or even my website, cfe.sh, and search for Django courses on there. Now, I'm also going to be using Visual Studio Code to write some of the code, but really most of it's going to be done in Jupyter Notebooks, at least for the beginning of it. Jupyter Notebooks are an interactive way to run and write Python code so that we can just share these things really, really easy. Now, the way we're going to share it is by using Git and version control, and of course, the GitHub repo, which is available on cfe.sh/GitHub, and then just navigate to the Talk to Django repo. Again, the Django part of this is really just the models themselves. Once you understand this, you can start building out a lot more full-featured Django projects as you see fit. Now, the way we're going to be able to store the results of all this data is thanks to Neon. Neon and I, of course, collaborated on this course itself, but they are serverless Postgres, and they have Pgvector built in. Pgvector is going to be a critical component so we can actually talk to Django. So we can do things like, hey, what were my most active users last month? Stuff like that. That is exactly what Talk to Django is all about, what this series is for. So at this point, what we need to do is set up our project, and assuming that you have 3.11 installed, you will be ready to do so. Let's take a look at how to do that right now. Go ahead and open up your command line. In my case, I'm using terminal. I will be moving over to VS Code shortly, but the idea here is you want to create a Python virtual environment using Python 3.11. So if you're able to do this, great, you're in a good spot. If you're on Windows, of course, it's going to be something more like an absolute path to python.exe and then -version. That, of course, if you're using Windows PowerShell, if you're using WSL or Windows Subsystem for Linux, which I highly recommend, then you'll be using something very similar to this, but of course it'll be with Linux. With this in mind, I'm going to go ahead and navigate to where I want to store this project, which is going to be in my dev folder, and I'm just going to make a directory called, talk to Django, and then I'll cd into that directory. So at this point, you have the option to, of course, clone the repo itself and work off of what we have, which is exactly what I'm going to do. I'm going to git clone that repo into this folder, and it's just going to bring in a few basic things. But by the time you're watching this, this will not be basic things. So what you would want to do is do git checkout and then start, and then that's where you're going to work off of. Obviously, you can change the repo itself. You could always remove the Git repo that I have, or you could just use the same one. But the point is, we now need to create our virtual environment using Python 3.11 and then do something just like that. So to start out, what we're going to be looking at is we're going to be doing some things around semantic search. So the reason for this means that we actually have to use some basic string of text and then turn it into what's called embeddings. This will make a lot more sense once we actually do it, but the idea is I want you to do some basic installations to start out, just to make sure that we have all of those things in. The first one is going to be Jupyter itself. That's Jupyter with a Y, and we're going to go ahead and do sentence transformers, just like this one right here, and then we're going to go ahead and do pip, and then we'll go ahead and do -- upgrade. This, of course, is upgrading it or installing it in the local virtual environment. Now, sentence transformers you might want to have on your entire user. This is one package that is like sort of a caveat to virtual environments. As I've seen, many people have more success if it's installed on your local machine than your local user. In my case, I've had no problems with it in a virtual environment, so I'm going to keep it in there. So I'm going to go ahead and run this installation. The point of me showing you this at this time is to make sure that both of those packages actually work inside of your Jupyter notebook, because if they don't, you want to diagnose those things right now before we actually start using them. So of course, I'll let these install. If for some reason or any reason whatsoever that your sentence transformers is not working, I'm going to show you an alternative using OpenAI. But the point of sentence transformers is to turn your text into an embedding, into a numerical representation of it, and we're just going to experiment with it. You don't have to know how that happens. You just have to know what you use when you need to use it. That's the key as to what we'll be doing here. Of course, learning how it happens or how to turn something into an embeddings model is definitely interesting, but outside the scope of this one. So let's let this finish installing, and then we'll go ahead and bring up Jupyter and then also create our first notebook. Great, there it is. It's all done. So now I should be able to do Jupyter and then notebook just like this. And this, of course, will open up an interactive terminal for me inside of my web browser. Now, if it doesn't open up, you can always just copy this string here, or if it opens up to a blank page for some reason, copy that string and then open it up, switch the URL if you have to, or of course, if you see to log in with the token, this is the token right here. In my case, I have no issues whatsoever. So I'm gonna go ahead and open this up in my main, Arc browser here, and I'm gonna go ahead and create a new folder inside of here, and we're gonna call it Notebook itself. Inside of Notebook, or rather Notebooks is probably what I would rather name it. So let's rename this to being Notebooks. And we'll open that up. And we'll go ahead and say new, Python 3. And we're just going to go ahead and call this our hello world. And I'll go ahead and do, it's like one setup hello world. That's it. And all I really want to see here is that my sentence transformer model will be imported. And so this model is definitely going to change over time. So if you need to search for sentence transformers on Google and see which ones that they have available, you totally could. So this is basically the process we're going to be going through here very soon, but I'm going to do it very purpose-driven for Django and Django models, not just general data like this. So we'll be able to use it in other contexts. So what we want to do is we want to run this cell. The way you do it was with Shift and Enter. That will actually run that cell for you. And all I want to make sure is there's no errors here, or if it's downloading anything and actually does that download process as need be. When it comes to machine learning models, that often happens. You download a bunch of external things to make sure that they're running and they're running correctly. If this fails, you can stick with me because I will talk about all of the things that it ends up doing, and then we'll look at how we do it with OpenAI instead of using the sentence transformers. In other words, a managed service versus open source. Right now, we're doing just the open source stuff. So I'm going to let this actually finish just to make sure that it is working. If there are errors, we'll jump back in. My downloading process finished. Now there's a notebook warning here about how the progress would have shown up, but in my case, it just didn't show up based off of this warning. It's not a big deal whatsoever, but it did install. It actually is in there. Then I also want to import NumPy as NP. This should have been installed with sentence transformers just to make sure that these things are being imported. Some systems, especially Linux systems, you might have additional installations you'll need for NumPy itself. But now that we've got some of these fundamentals down, let's take a look at how we can start using these sentence transformers themselves. To make it easier to track where we are with the video section as well as the repo itself, I actually will continue to make new notebooks off of the video that basically pick up from where we left off with maybe some minor changes. But the idea is this is where we're going to start off with. We have our model in here. Everything's imported. We're ready to go. We're going to create our first embeddings. Now, embeddings are really about text. Your text itself, unstructured text, needs to be adjusted. What this means is like your paragraph text. If you have a blog post, the content of the blog post, not stuff like timestamps or anything like that. You can implement timestamps this way, but you won't necessarily need to. That's what we'll be doing later when it's more advanced. So the idea is we have some doc like this. The dog jumped over the cat, and we want to turn this into embeddings. We want to turn it into a numerical representation of this text. Now, it's not just numbers as in their position. That's actually really easy to do, right? So if we were to grab 0 and then do something like split and split it up based off of spacing, what we end up seeing is, well, a list of the items in there. That's not what we're talking about. And of course, these list items all have an index number, index 0, 1, 2, 3, and so on. That's not a numeric representation of the text itself. That's a numeric representation of the position of the text itself. But we want this representation so we can compare it against other text that's almost the same. So keep this in mind for a moment. We're going to go ahead and actually leave it in here. I'll come up here and say split docs, something like that. So we'll keep that in mind for a moment. And then we might even do something like sorted on top of this so we can see exactly what's going on. Not quite the same stuff once it's sorted like this. Okay, so now let's go ahead and turn this into a numeric representation. Still with just a list of this string here. We will add more strings in the future. For now, we're just going to do it just like that. Okay, so to do this, we use the model itself, and it's just model.encode of these documentation, and we hit enter. This will give us back a numeric representation. This might not mean like much to you right now. We'll see what that means in a moment, but I want to just actually have it as embeddings equals to that result, so that when I call embeddings, I see something like this. Now, that's the first document. The next document we'll do is something very, very similar. The cat jumped over the dog. These are almost identical, except the actual animal that's doing the jumping has switched spots. Now, if you actually did the split doc thing with this same docs2, we are going to get, we'll call this split doc2, something like that. So we'll replace this one with the docs2, and we'll go ahead and hit enter. This is very similar. In fact, it's identical. These are the same strings now, or same lists overall. Now, I'm not going to go through the Python comparison itself because that's not why we're here. We're here to do the embeddings comparison. So when you go into the Python of it all, these look like the same exact thing. But if you go into the embeddings, they don't look like it at all. So we're going to do embeddings2 equals to model.encode, and we'll go ahead and do docs2. So we now have two different embeddings, embeddings1, embeddings2. So now we can actually compare these two to see how similar they are. Now, if we compare it to itself, it's going to be similar every time. So if we do model.similar or similarity, and then we do embeddings2 to embeddings2, we get a 1. If we do embeddings1 to embeddings1, we get a 1 as well, as in it's completely the same. I'll explain the positions and all this stuff, but the point is you see a 1 here. Now, if we were to change these things from embeddings1 to embeddings2 and do that similarity, we've got a 98% match. Why is it 98%? Well, it's because the animals are similar. But of course, if I were to change things in here, let's go ahead and change some things down here. I'm going to do embeddings3 now. This time I'll just put the doc in directly here, and I'll say the weather is hot, right? This is not at all like the other two. So now we've got embeddings3. So once again, we can see how similar it is to either of the other two, and we see that it's not similar at all. In other words, these things are now being ranked based off of the contents that are in there. Now, your contents could get a lot bigger than this, and they should. But the point here is we have the ability to actually see which one is similar and which one is not. What if we said something like the dog is hot from jumping, right? That actually seems to be pretty similar to these as well. Now the similarity has gone up. It's now closer to 1. 1 is the highest, as in it's identical, as we saw just a moment ago when we did the identical ones, right? There's identical. There's not quite identical. There is close, but not quite there. And then, of course, if we went to the other one, like the weather is hot, and then we compared that one to any of the other embeddings, we will see this is the opposite of that. So really, really not identical. It's not quite the opposite, but it's definitely not similar either. So that is it. What we do here is we start extrapolating on this concept of embeddings, of taking these numeric representations, any numeric representation, and comparing it against other numeric representations to see if they are similar. And if they are similar, then it's a good match. Then it's a good query itself. So that's the point. We want to do semantic search with text. So if you think about this in terms of the document being your database full of a bunch of different text embeddings, and then you add a query of some kind, you do some similarity, then you'll get a result back, and then boom, now you have a search result based off of semantic text, actual realistic text based off of what's in the data. But let's continue along this line and actually build out something that's a little bit closer to what you might have in a database. When I think of embeddings and semantic search, I like to break it down to being something a little bit more simple like this. We've got a list of numbers here and then a query. We want to know what index value 5 is at. So to do that, we can do data.index and then pass in that query. And then, of course, it gives us the index value of 4. Starting at 0, we could obviously do the calculation to figure out that 5 is that correct index. But if we did 5.3 and did that same thing, we get a value error, right? Of course, we get a value error. 5.3 is not in this list. But those of us who understand rounding and simple numbers, we can see very simply 5.3 is basically 5, right? It's not 5, but it's basically 5. And so this is the idea that, oh, maybe it's like a 97% match to 5, right? That's probably the wrong number itself, but the point isn't that it is exactly 5, but that it's a 97% match to 5. So that's exactly what we're trying to do with our text. So when we think through all of our different text items that we have, we go back into our texts. What we want to do is each one of these things, we want it to turn into a numeric representation. That numeric representation happens to be a NumPy array. It happens to be a matrix of a bunch of different numbers. It's not just one number. It's a lot of them because the data itself is complex. It's a lot more complex than this data right here. But the concept is still very similar. We want to guess what percent match the query is to the data set that we have. And so let's take a look at how we can do that with multiple items in here. So what we had before was we had the single embedding, and we can see the embedding in here. It has a lot of numbers in there, a lot of data, a lot of dimensions going on. If we do embeddings.shape, what we can see is it's just one data point, no surprise, it's just this single list right here. And then in there, there's a lot of different dimensions that are related to it, kind of like columns in there that are related to the item itself. And so if we look at the very first item in here, in the embedding, we see there's the array itself. And if we look at the very simple element in here, we get a NumPy float that is that data at that particular point in the actual embedding itself. Now, I don't want to go into the NumPy of it all because that starts to get a lot more complicated. The idea, though, is there's a bunch of different numbers that all represent this string of text. All of those numbers are represented as NumPy floats, but of course, there's a whole array of them, a list of them that represent that whole string. And that's going to be true for all of these other ones as well. So the nice thing about using sentence transformers is it's really easy to turn all of these strings into embeddings. Now, this isn't the only way to do it, as I mentioned before. We'll see how to do it with OpenAI very soon. But the idea is that we've got all of these documents in here, and we can just go ahead and combine them into one. And now it's going to go ahead and change how the embeddings shape is. So if we look at it now, after we run these, we can see that it now has a shape of 3, and it has, some value in here related to the dimensions. This is going to be different based off of what embedding model you end up using. So OpenAI, it's going to look like something different. At some point, sentence transformers, this is also might look like something different. So do keep that in mind, and I'll repeat it again in the future. But the idea is when you create an embedding, the way you query it should be the same embedding, the same way you create those embeddings, which in other words, we want to go ahead and change this something a little bit different, which we'll do soon, but basically something like get embedding that is going to be used for our data set as well as our queries. Okay, so we'll come back to that. But now we've got new embeddings with a new shape as we see right here. So all I want to do is I want to use this query here and compare it against this one. Very similar to like what we did with these numbers, but now I'm going to go ahead and use it as a string, and this is when we'll go ahead and do that querying itself. And so now it's giving me similarity from each embedding, each one of these things. So there's actually an index value that is corresponding. So this first one is for this first one. This second one is for this one, and so on. And this is the percentage likelihood that those things are the same. Now, I actually want to see this a little bit more ranked out and listed out a little bit closer to what you would actually want as your end result, but the idea is still the same. Overall, creating multiple data points is definitely possible. So if you were to add another one, the cat is yellow and the dog is red, which is kind of weird, but whatever. We'll go ahead and actually bring it in. We've got new embeddings now. We've got a new query now, and we can see that this is the closest match in here of all of them. Again, 1 being the highest number that it could possibly be. So this is like a 91% match if you round up. That's the idea. Now, I will display this in a little bit, but the point is at some point we'll have so many documents that it's pretty hard to just put them all in this format. We'll actually want to store them in a database. So what we want to do before we get to the database point is actually turn this into a little bit more structured data as it might appear in a database, like having an ID and this text. Let's take a look at how we do that right now. Now we want to make our data a little bit more complex by adding in IDs to each row. The idea here is we want to work towards an actual database. It's not going to be efficient to query the entire database, get all of the text that's in there, and then embed all of that text all at once. It's going to be a lot more efficient to get each row and then embed it based off of rows themselves. So before we go to that complexity, let's see how we can do it with this simplicity. So the way we're going to do this is by actually addressing the fact that these already kind of have IDs. That is the position number. So if we did something like docs of 0 or index 0, that is essentially the ID of 0, basically. So let's actually turn this docs into something that better aligns to that. So we'll go ahead and do we'll call this our documents equals to an empty list. Then we'll go ahead and iterate through each doc. So we'll do for x in docs, and then we're going to go ahead and print out x. Now what I want to do is I want to append these to these documents as a dictionary. One of the ways we could do this is we could do something like range of len of those docs. And of course that will actually give me the index value for each one. Or we can use something a lot better than that and use enumerate. And we can just say for I x and enumerate those docs. And now we can see that we can actually use both the data and the index value itself. Very simple. Now what we want to do is say row equals to, we'll use something like index and, let's go ahead and say index and then put it equal to I. And then we'll go ahead and put in data, and that's going to be equal to x. And then not hit shift enter every time like I've been doing. We'll go ahead and do documents.append row, and then we'll go ahead and look at the documents themselves, and we'll go ahead and run that out. And there we go. So now we've got our index value. This is a different data set altogether. So that's all nice and good, but the point of this is that the actual structure of the final data set doesn't matter so much as to what we're doing. This structure I'm not actually going to end up using. I'm going to use a different one just so it actually corresponds closer to what you would do within a database itself. So here's the data set we'll end up using. And of course, we could use this data set or attempt to use it on embeddings itself and do data set, hit enter, and we get this, object of type int has no length, as in it can't embed the IDs in here. Now, what we can do then, instead of having it this way, is we can actually come in and iterate through all of these dataset items. So we'll go ahead and just say for x in dataset. Now I can actually print out, or we'll just go ahead and do our embed as in model.encode, and this is going to be just simply x.get of the text. And that will give me my different embeddings in here going forward, right? It's really just that simple. It's not really that different than what we've seen before, but now we're doing them one by one. And so the final actual data set that I would end up using would be something like our document embeddings, and we would put this into an empty list. This is where we can then go ahead and append those embeddings. Now I could just do one single embedding, right? So I could absolutely show where we just have all of the embeddings and it's literally just that. But this, of course, isn't showing me the IDs in there either. So the embed itself can be something a little bit different, and we'll go ahead and say our final data is a tuple actually of x.get of the ID along with the embedding itself, and then that's what we actually append to this document's embeddings. So each one has the actual ID that's in here. Now, the actual number of the ID doesn't matter at all, right? So we could say ABC and still run this, and the same thing still works. So the ID itself is not unique at all, and it's not going to be used at all for the actual similarity search that we go through forward. The point of this is that our document embeddings have an ID of some kind. there is that metadata. So other metadata we could put in here. And in fact, we could still use it as dictionaries. We could still do an iteration like this, and just instead of it being data, it's just the encoded data or the embeddings itself. But we're going to leave it in as this, just the list of items with a tuple that's in there, or tuple that's in there, with the first index value being the ID, the second one being the actual embedding. Now the reason for this is the next part is our actual query. So we'll then do our query embedding, and that equals to, well, model.encode of that query. There we go. So we've got our query embedding now. No big surprise there. And obviously no big surprise if we look into our document embeddings and we look at the very first one, and then we get the second element in there. We can see the embeddings in there for that are going to be very similar for our other one. Okay, great. So now what we want to do is actually compare these items in here all together. Okay, so we've got our query embedding, and so the way we compare them now is by going through all of the document embeddings. So then we'll go ahead and say our results are equal to that, but we'll go ahead and do for our our embedding in our document embeddings. Well, actually, let's go ahead and say doc in document embeddings, and we'll go ahead and get our doc ID is equal to the doc of 0. Now we'll go ahead and give it a rank of some kind, which is going to be equal to the model similarity of the embedding. So we'll go ahead and say doc embedding equals to doc of 1. Now we bring this in right here, okay? And then we're going to go ahead and encode. We already have the query embedding in here, so we're going to go ahead and do the comparison there. There is our result rank. So now what we can do is we can go into our results here, and we can say, well, results.append, then we can append based off of basically the same positions. So we'll put in a tuple here of the doc ID, comma, the rank. And that's it. And then our results will give us that final result as to how these things compare. Now, one of the things you might try is get this out of a list here and see if that makes any difference. It doesn't. The result, the way this actually works, is clean. It makes it really easy to not make mistakes like that. That was a really simple mistake to potentially make, whether or not you have a list in here or not. Now, it might actually change if you do it with multiple lists. Let's take a look. Yeah, that actually doesn't work. But the idea being that how you put this data in is fairly flexible thanks to the sentence transformers, how that actually works for creating your actual embedding. But now we've got an actual result here. So with this result, what we could do then is we could actually go based off of the rank itself. So let's go ahead and actually sort these things with sort, key being the lambda x, and then x of 1, and then we'll go ahead and say reverse being true. Take a look at that, and this should be key equals to lambda of x, x of 1, and put a comma after this. A lot of syntax errors there. And so then that actually resorts it in line, and now gives us the actual IDs that are available to us. So now we can say for result in results, we can get the actual data. So the the actual original ID, so the dataset ID is equal to the result of 0. And let's make sure that that's the result. The rank being the result of 1, and then the actual dataset item itself would be going based off of this dataset itself. So we could actually iterate through all of those items there, which this query isn't necessarily efficient, but we'll go ahead and say that the document is equal to next of the doc for doc in the dataset if doc of ID equals to this dataset ID right here. And then we'll go ahead and print out these results here. So we'll go ahead and print, let's say, the dataset ID, the rank, and the doc. And there we go. So it gives us the rank, the cat is yellow and the dog is red, based off our query up here. the cat is yellow and the dog is purple. Great. Let's change this query so we can see it. It was cold yesterday. Run this. Now, boom, it did re-rank these things. Notice that these aren't similar at all in terms of how the ranking of these results ends up working, right? And so if I were to come back up into my embeddings here, let's go ahead and just add a new one in here. And we'll go ahead and give the ID of 5 just so that the data set actually comes through. And now I'm going to go ahead and say the dog jumped over the purple cow. And we run through again. We create all the results and we re-rank everything. And once again, we've got the purple cow. That's strange that that's closer, but we'll go ahead and say something like the purple cow is a great book, which it is. And there we go. So now we've got something that's similar to that. Granted, it's not that similar because it's not even close to 100% similar. Like if I said something like the exact same query and did something like the dog jumped over the, green cow, also kind of ridiculous. That one is a lot more similar than what I just said, even though there was a matching text in there altogether. Embeddings are so cool. Just knowing this, I think, can actually open up a lot for you. And of course, what we want to do now is we actually want to move this towards actually being in a database itself. Understanding the fact that all we did was add the data set to be a little bit more complex. So finding the result was a little bit more complex. But overall, we get a data set here. We turn that data set into embeddings. Then we do a query, which also is an embedding. Then we compare them one by one. And so that's where this result comes in. Now, this comparison could take a long time if it was a big data set, which is why this is not necessarily efficient either, but the idea is still there. It allows us to actually compare different things and then find what the end result would end up being. Now, how we do this in the database is definitely different, but overall, this is what semantic search is all about. You have a bunch of data that's just raw text. Now, it's called unstructured because this is a structure right here. This is a dictionary structure, but the text itself is not a dictionary structure. There's not a really good way to query this text other than, matching like dog or jumped or something and finding the index for that. Semantic searching, like what we're doing here, is the way to actually be able to query that individual text itself based off of other text itself. It's pretty cool. So we want to build on top of this. So let's go ahead and start doing that. Now we're going to go ahead and create our Django project, create a Django app, and then add in Pgvector Python. Now, what this will allow us to do is to store an actual vector into our database, into our Postgres database. This didn't used to be supported. There are something called vector databases out there, but with Pgvector and Neon, you just don't need a vector database. You don't need a separate database for your vectors, which is super nice. So there's a few different ways on how we can implement Pgvector. I'm not going to go into those just yet. We will do that soon. First, let's just start up our Django project itself. So the way I'm going to do this is opening up VS Code. I'm going to open up a folder, and I'm going to navigate into where I stored my Talk to Django project in my dev folder. And this is where I'm going to be working pretty much throughout. So I can close out my terminal where Jupyter is currently working, just so that I make sure that I'm working only in the VS Code terminal, which I can just toggle open. Learning that toggle is highly, highly recommended. And of course, you still might need to activate your virtual environments inside of that terminal as well. So with this in mind, I'll go ahead and run Jupyter Notebook in here. Keep that up and running because I will use that also with Django throughout this project. We will integrate that very, very soon, just not yet. Next up, we're going to go ahead and create our Django project now. So once again, we need to activate our virtual environment. And then I need to make a directory called src. And I also should right away create my requirements.txt. So normally what you could do is create the requirements first, but what I'm going to do is do pip freeze and then into requirements.txt. You will see this every once in a while whenever it comes to development environments and stuff like that. These are all the requirements of the current state of things. I actually don't want to have all of this. I don't need to write all of this out. So I'm just going to go ahead and cut out the things I for sure will need going forward. One of them is Jupyter. The other one is the sentence transformers. And I don't know if I need much more than that at this point. So I'll go ahead and get rid of everything other than that. Pretty sure I didn't add anything else. Okay, so with that in mind, let's go ahead and delete all of these and now add in Django in here. In this case, we're going to do Django is greater than equal to 5 and then less than 5.1, only to make sure that no changes in the future with Django will be different. 5.1 is probably not going to be much different than 5. 5.2 is probably not going to be much different. But just for the sake of this series, I'm going to go ahead and keep it into that organization there. So I'll go ahead and do pip install-r requirements.txt. So another thing I'm going to actually bring in is the OpenAI package. The way we use the OpenAI package has changed a little bit over time. So do keep in mind how that ends up working for your particular project. We, in the long run, are not going to be using sentence transformers anymore. We're going to move towards using just OpenAI. But of course, you could use sentence transformers. It's just not necessarily something we're going to do. Okay, so with all the requirements installed at this point, I'm now going to go ahead and open up into another terminal window. This time it's activating my virtual environment on its own, probably because requirements.txt is in there, as well as this venv. I'm going to go ahead and now jump into SRC here, and we'll do Django-admin and start project CFE home, period. I call all of my Django projects CFE home only because then the configuration for Django is always in CFE home. That's the way I do it. I recommend you find something very similar, but the idea being the main Django configuration, as in where ASGI, settings, URLs, WSGI, where all of those live are going to be in a consistent location for your project in general. Okay, so the next thing is what I want to do is I'm going to go ahead and create my first app, which we'll call Python manage.py, start app, and we're going to call this blog. So the reason I'm calling it blog has to do more with the fact that I just want to use very standardized kind of data than more unique data at this point. So in the future, maybe I'll change that, or you could change it at this point as well. But the reason I want this is just to make it really, really straightforward and simple on us in terms of the modeling itself. So the way I'm going to do this is very straightforward. Also, we're going to go ahead and create a blog post model, which will take in title and content. Now, the actual content itself, I'm going to make it required so that I can eventually create embeddings, which we'll do in the next part. But the idea here is a very simple model in terms of Django. Now, if you're familiar with Django, this is obviously not that big of a deal. If you're not familiar with Django, this is essentially creating a row that has an ID. So models auto field in here is hidden, but it does create an ID. So basically, you'll end up with a database with data that looks like this. It's just simply ID being 1, then it'll be something like title being your title, and then content being your content. That's what's happening with this blog post model. And if we were to add in something like a timestamp, we'll do models.datetime field, and we'll go ahead and do auto now add. This will be true. This field itself will be set when it's added into your database. So it's going to be a timestamp like timezone.now, which again, I'm not going to actually fill this out, but the idea is each one of these fields maps to something like this. Now, this is where we're going to go with Django. We're not going to go that much more complex than this. We will add a few other, items in terms of functionality for this, how we can create these things, how we can do aggregations and all that. If any of this is confusing to you and you want to learn more about Django, go to my YouTube channel, check out the Try Django series. That's also on my website, but you can find it at cfe.sh or cfe.sh/YouTube. Now we're going to go ahead and implement Pgvector for our Django project. Now what's going to happen here is it's giving us support inside of Postgres to actually use a vector field. So we can do queries with vectors. So we can look for similarity things like distance between two vectors. We'll talk about those distance things later, but the idea is we need to add this field in. Now, I would imagine at some point Postgres will have this natively in Postgres. Right now, it's not native. At some point, Django will have this native in Django as well. Right now, it's not native. Pgvector and Pgvector Python make both of those things work and possible. Now, the other part is your Postgres database service needs to support Pgvector, which I think a lot of the modern ones are starting to do. But of course, Neon helped pioneer this. So that's a big part of the reason why you might want to use Neon in addition to serverless. But the idea here is we're going to go ahead and implement this now and see if it even works within SQLite, the default database that Django has. So let's go ahead and do this. We're going to jump down into Pgvector. We're going to do our pip install Pgvector, which I think we already have in our requirements. But let's go ahead and make sure that we bring it in there. And I'll run my pip install. So pip install /, or rather -r requirements.txt, because I'm in the src folder at this point, which is why the /. Okay, so now that we've got that installing, I'm going to go ahead and scroll down to the Django portion of it all. It's very straightforward. First off, we need to implement the vector extension inside of the migrations, and then we need to also have it into our field itself. So the idea is I actually don't need these to happen at the same time. I want to actually implement the vector extension before I go ahead and do the field itself. So inside of settings.py, I want to go ahead into my installed apps. I'm going to go ahead and bring in the blog here. Now I'm going to go ahead and run inside of my Django project. I'll run python manage.py, make migrations, and hit enter. Now, for those of you who are not familiar with this process, what this is doing is it's telling Django to prepare files to make changes on the database. We haven't made the database changes yet, but this is just preparing that. It's very common in migrations. Hopefully you already know this part, but if you don't, the idea is we are going to let Django tell our Postgres database or our SQL database what fields need to be in there and what tables. And that's what's happening here. We're creating this model and we've got a bunch of fields that are being added. So inside of these operations, what we can do is we can add in this vector extension here. We're going to go ahead and bring it in, and we'll go ahead and call it just like that. Now, I actually want to inspect this vector extension itself. There's not a lot to that class itself, but I want to see what it is that's going on. And really, it's just making this one single call of create extension if not exist for the vector extension, right? And so you could actually see this in other places, like create extension if not exist. So here it is right there in SQL Alchemy. Basically the same thing. So you really only have to do this one time. That's kind of why I'm bringing it. You shouldn't have to do it on every time you need to use this vector field. You should only do it one time, and then all of your other vector fields going forward should work just fine. With this in mind, let's go ahead and add in a vector field, closing out some of these inspections here. So back into our models here, we're going to go ahead and import our vector field from Pgvector, pgvector.django, import vector field, and now we've got our embedding equaling to the vector field itself. Now, one of the arguments in here is the dimensions. Now, we can also add in stuff like, I'll go ahead and just do 300 for a moment, but then we can also add in stuff like blank equals to true and null equals to true. So these extensions actually make, or these dimensions rather, make a big difference in how you end up using this. So this actually goes back into what we did with our notebooks, going into embeddings with IDs. If we take a look at this, we actually already know what our dimensions would end up being for this. So let's go into this, and I'll just go ahead and run this out. And we want to grab any given document embedding or even our query embedding right here. And I want to go ahead and do .shape. Hit enter. And what this will show me is the dimensions that this particular sentence transformer model ends up using for the embeddings. It's not actually that big. So we could start off with just that as our dimensions. This is probably just fine. But as I want to go into production and I want these embeddings to be as, well, good as possible, I'm going to use something different. So what I'll do is I'll look for OpenAI's embedding model. The reason I'm doing this quick search here is because these are going to change. These are going to improve over time. So you're going to want to know how to actually look them up and find them. So we've got our different embedding models. Here's the one. It's the small model. And so we want to find the actual size. And so if you scroll down, you see the length of the embedding vector will be 15364 for this model, or 3072 for this model. So those are the actual fields that we want to really set. And where to go? Let's go ahead and find it again. Quick search again. And for whatever reason, it's not very easily found, but you will be able to find different vector sizes for this and all that. So this actually brings me to one more point, and that's going to be our actual embedding. We'll go ahead and say our embedding model, and I'm going to set it equal to this for right now, and then our embedding size, or maybe our embedding dimensions, we'll call it embedding length, which is the dimensions in there, and I'm going to go ahead and use that one. Okay, so once again, I'll go ahead and actually link out where these are in our code here, just so we can find it again if we need to, if we want to do a bigger embedding. Doing the small one is what I definitely recommend. It's going to be the least expensive, but also when you're doing searches like this, having the least expensive one is definitely a good idea. So there we go. We're going to use that as our embedding length because we're going to be switching over to using OpenAI. And that's it. That's all we need to do now. All the other part we need to do is run our make migrations again. And so we've got this no module scopg2. So that's another requirement we need to bring in here. So we can use scopg2, or we can use number 3, which just doesn't have a 2 on it. And we want to bring in binary in here. So either one, I'm going to go ahead and comment the ones out here. I think using 3 is the preferred method, but you want to use one of them. So let's go ahead and do our installation once again and just make sure that that binary is coming through. This is just to make sure that the extension works correctly, as well as all of the other Python connections to Postgres itself. This is the older version. This is the newer version. So if the newer version is not working, just use the old version, and that should be just fine for you in terms of working going forward. Okay, so with this in mind now, let's go ahead and run our make migrations again and see what we have here. So this is, of course, going to add another field into our migrations here for our embedding vector. This is another place we could put in the actual vector extension. The reason I like doing it before is just to make sure that this is activated, and then later, if I needed to, add other vector fields, I don't have to worry about it working. It just works just like that. Okay. Now, before we apply these migrations, we actually need a Postgres database with Pgvector installed. If you remember, the operation of vector extension will enable that Pgvector. It does not necessarily install it. Maybe at some point it will, but right now it does not. So there's actually a couple different ways on how we could go about using a Pgvector ready Postgres database. One of the ways we could do it is by using Docker in something like Docker Compose and using the official Pgvector container image. This actual setup process is almost identical to regular Postgres, but of course this comes in, you need to know Docker, you need to know maybe Docker Compose, then you need to figure out a strategy to go into production, and then you need to manage it. For all of that complexity, it might be nice to learn about for sure, but for me, I want to be production ready, which is one of the reasons I'm using Neon. The other one is Pgvector is ready for you. It's ready right away, and it's serverless, of course. And the final one, of course, we actually work together to build you this course. But the idea here is we need Pgvector ready to go. Neon does that for us really, really easily. So go to neon.tech/CFE to actually get your account. This just gives me credit that I actually sent you there. But the idea is you want to sign up or sign in. In my case, I'm just signing in to my account. I'm going to go ahead and create a brand new project here. The region as to where you're going to put it, you should either put it where you're going to deploy into production, or if you're just testing, put it close to where you are physically. In my case, I'm just testing, so we're going to go ahead and create talk to Django as a project, and then I don't really need to change anything else. I can just use all the defaults. I want to use the latest version of Postgres, but you could use other versions that are supported as well. Go ahead and create this project here, and then what you'll end up getting is a connection string they can use. This is the connection string I'll end up using. Now, you could always use their Django configuration and setup, but they use a different .env package loader than I do. I use Python decouple, but the general idea is roughly the same as this one. So what I'm going to do here is I'm going to go ahead and copy my connection string, and I'm going to go into my root of my project, and I'm going to create .env here, and we're going to call this our database URL, and I'll paste in that connection string. You actually don't need quotes on here with .envs. Sometimes you might, but in our case we don't. I'm just going to put it in there just for syntax purposes inside of VS Code. Next, what I need to do is be able to load this in. The way we do that is with Python decouple, and then I also bring in DJ database URL, which basically just takes this connection string and turns it into something a little bit more usable in terms of our Django project. Okay, so with those added, let's go ahead and install them with pip install -r requirements.txt because I'm in the root of my Django project. With those things installing, I'm going to jump into src here, into settings.py. At the very top, we'll go ahead and import from decouple. We're going to import config, and then we'll also import DJ database URL. And so what I want to do is down underneath my standard database here, I'm going to go ahead and bring in my database URL, which is equaling to config, and this is going to be my database URL. The default is going to be an empty string, and then we will go ahead and cast it as an str rather. So the idea is this is going to load in my environment variable if it's available. If it's not available, it's going to be an empty string. Either way, it's going to be cast as a string value, which is really nice for a number of reasons, but I'll show you one in just a moment. Then I'll go ahead and say if database URL is not equal to that empty string, this is where I'll redefine my databases, and we'll come in here just like this. The default is no longer going to be this default. Instead, it's going to be DJ database URL.config, and then this is where we'll pass in our default being equal to that database URL string, and then we'll also add in the connection max age being 0. The reason we put it in as 0 is because Neon is serverless, so it's just going to reconnect basically every time. Now, for those of you who know Postgres really well, might think, oh, this is not incredibly efficient. But the thing is, Neon does it really, really quick and makes it really, really efficient. But you could always play with different database options inside of Neon, like pooling, connection pooling, and all that. I'm not going to worry about that right now. I'm just going for the most minimal setup as possible. And so this is going to be it. So the next thing with config here, what I want to do is I'm just going to go ahead and do config. And this is going to be Django debug. We'll go ahead and cast it as a Boolean value and put the default being false. So this is actually really nice for production and development. This is another reason I use Python decouple. Then I go into .env and do Django debug being 1. This will cast it as a Boolean value, as in true and false. If you do it as 0, it's going to be false. If you do it as 1, it's going to be true. Both things are really nice and why I use Python decouple, among other reasons. If you don't actually declare something as a default, it's going to run errors as well. Also really, really nice. Okay, so the idea is now we have our database all set up and it's pretty much ready to be migrated. So let's go ahead and give that a shot with python manage.py migrate. Of course, I'm in the root of my Django project, and here it goes. It's actually migrating into Neon. So we can actually verify this by going into our database itself for Talk to Django, and we can see all of the different things that are coming in here for our database. At this point, it doesn't actually have a whole lot going on yet because we don't have any data in here yet, which we will add very, very soon. The next thing I want to do is add in my super user, create super user, and I'll just go ahead and say CFE as my default, and then a whatever password. This doesn't matter so much because we're only doing this locally. If you plan to deploy this database into production, then yeah, go ahead and get a much more robust password, maybe using something like OpenSSL. But the idea here now is we should have a Django project with a production database. And so let's go ahead and just run that database in here with python manage.py, run server. And all I want to do is make sure that this runs and I can log in to the Django admin, which then shows me that everything's working great. I did create a super user, so back into Neon, I can see that there is that super user in there in that database table. This is another really nice reason to use Neon is we can actually just look at the actual database tables that we already have. Okay, cool. Next up, we're going to go ahead and open up our Django project at the local host here. hitting control click on this inside of VS Code will actually open it up in your web browser. Super nice shortcut if you weren't already aware of it. Next up, I'm going to go ahead and log in here. I use this same username and password for a lot of development projects, which is why it's just already there. I can log in, sessions are working, Django's working, we're ready to go. So at this point, we now have seemingly everything ready for actually using those embeddings. Now we actually need to test it in a similar way that we have been, and that is by using Jupyter with Django. So now we're going to go ahead and integrate Django with Jupyter. So inside of our notebooks here, we're going to go ahead and create setup.py. This is a single file that's going to allow me to actually have my notebook directory connect into my Django project with all the database and all that sort of stuff that's in there and all the models. There are third-party packages that do this, but it's so simple. So we're just going to go ahead and do it on our own. First off, we're going to import OS. We're also going to import pathlib. And we're going to go ahead and import the sys package as well. And then we'll also do, that should be it in terms of our imports. Next up, what we're going to do is our notebook directory, or nobs-dir. So the reason for this has to do with we want to know where this directory lives. We use pathlib for that, so we use pathlib.path, and it's going to be of this single file here. Then we grab resolve, and then we grab the parent. Resolve is going to be the absolute path to setup.py. Parent is going to be that directory. And so then our base directory or our repo directory is going to be equal to, well, nbsdir.parent. Great. So what we want to do is keep these things in mind. Next up is going to be our actual Django project itself. Going to be a little bit different than this, but overall we're going to go ahead and now say define init Django. We can pass in a project name. In my case, it's going to be CFE home. You could always change your project name as you see fit. We can also pass in the Django root, which in our case is going to be SRC, this SRC folder here. And now we're going to go ahead and do our project root being the base dir / Django root. Okay, so that's actually where we want to run our commands, which means we're going to do os.change directory to project root. That's it. So this will allow me to change that directory. We also want to do syspath.insert, and this is going to be 0 to the string of the project root itself. Then we're going to go ahead and add in a few things related to Django, which actually comes from manage.py. That's this set default environment variable here. The Django settings module, which is in this case CFE home.settings. But if we actually use the project name, then you could have a different project name and it should still work. There's one more command in here that we want, which is just simply os environ Django allow async unsafe being true. Again, just in setup.py for these notebooks, so it actually can run in those notebooks. Then we're going to go ahead and import Django, and then we'll just run django.setup, and that's it. So this is all we should need to do inside of our notebooks to connect Django to it. So if we do if name equaling to main, we will also just run this as well if we ever needed to test it otherwise. Great. So with this in mind, I'm going to go ahead and create a new notebook to attempt this process. So inside of my notebooks here, let's go ahead and create a brand new one. And this is going to be 5 connecting Django. And all I'm going to do here is we're going to import setup and then setup.init Django. I shouldn't have to change anything else for this. We're going to run that. Now I'm going to go ahead and do from blog.models. We're going to go ahead and import blog post, I believe is what we called it. Let's go ahead and just verify that. There it is. And I'm going to run that and do a query set call here, blog post.objects.all. What we should see is, well, just an empty query set because we haven't added anything yet. But this is showing us that Django is now connected with Jupyter. So we can do all sorts of things in terms of testing out our data and different models and all of that. It's just an interactive way to do it. A big part of the reason for that has to do with how we did these embeddings. We can go back and forth. We can try a bunch of different things out. Then if you ever look at this in the future, you can just run through the notebook itself just to make sure that it's all working as you initially intended. If something's wrong, then you could obviously change it inside of Django itself. then all you need to do is restart the kernel and then run it from there. And that's how you would actually go about doing it. Going forward, if you ever need Django, you just call this setup process just like we did. Now we're going to do a semantic search inside of Django with, of course, OpenAI to do our embeddings, Pgvector and also Neon to actually store the vector embeddings once they're done, and then obviously manually adding in and removing various points of data. So one other thing that I want to add in this blog post here, I'm going to go ahead and say something like can delete as models.boolean field default being false. The only reason for this has to do with the Jupyter notebook of it all. So basically like help text being use in Jupyter notebooks, something like that. Once we do that, I'm going to go ahead and create my migration. So Python and then manage.py, make migrations, and then Python manage.py, migrate. Now, the reason for this, of course, is if we go back into our semantic search stuff, we can now go ahead and do filter and then can delete being true, and then it qs.delete. So basically, we're going to delete that query set every single time we want to use this, and then we'll go ahead and create that query set once again. So there's a lot of different ways on how we could go and create this, but the idea being new data, or let's go ahead and say new data, and it's going to be equal to an empty list, and we'll just do for x in docs, and then we'll go ahead and do our blog post, and we want to give a title of some kind, and in this case, I'll actually enumerate this, and we'll go ahead and give it I and X. The blog title, we're actually not going to use in our embedding, although you could. I'm just not going to do it at this point, and I'll just do blog, blog post, and then I, maybe I plus 1. Okay, so there's going to be our title. The content we want is going to be these documents. So going back into our model, there are the two fields that we're setting by default inside of this enumerate. And then we're going to go ahead and do our new data.append that blog post data so that we can then do our blog post and .objects.bulk create of this new data. And so if I run all of these fields here, all I want to make sure is I have this blog post now, and then I can grab this query set once again, and we can get the count going, and it still says 0. I made a mistake here, and I should have put in can delete being true here. And so I'm going to go ahead and just come in and do all for a moment. We're going to delete everything, and then we'll bring back that filter. So what I just did is exactly why I like using Jupyter Notebooks. It's super easy to just jump back and forth without changing a bunch of things. So now we add it again, and then we get our blog post count. There we go. So now we have 4 items in here. The last kind of field that I want to do is recreate being true or false, right? And so this is where I'd then say, instead of having delete down up here, I would put it in here and just say if recreate. Then we go through that process of deleting and recreating. That's it. Okay, cool. So now I don't actually run this over and over and over again if I need to refresh my entire deal here. So let's go ahead and say recreate data, maybe a little bit more of a verbose setting here. Okay, cool. There we go. So now we have some blog posts that we can work with. So what we need to do is we need to actually turn them into embeddings because none of them have embeddings at this point, right? So how are we going to go about doing this? This is where OpenAI comes in. So in my imports here, right above my blog, I'm going to go ahead and import OpenAI. I'll hit enter. I may or may not already have this in here. So in my case, I actually did already have it in here. So my requirements, I did add it in, so it's already in there. So with OpenAI, we need to build out a client itself. So instead of import OpenAI, we're going to go ahead and do from OpenAI import the OpenAI class. This will be our OpenAI client. So down here, we'll go ahead and say client equals to that. And we try and run this. Of course, it's not defined yet. And as soon as I run it, I think I'll get an API key problem. So we absolutely need an OpenAI API key. So to do that, we jump into OpenAI. We go into their products, or we just log into their API, however you end up doing it, and then go into the API itself. Then you're going to go ahead and jump into the dashboard and find API keys here. There's a lot of different ways on how you could actually go about doing this. Next, you're going to go ahead and create a new key. We want it to be restricted, and we only want it to restrict it to probably our chat completions and embeddings, but really just embeddings is all we need at this point. So we're going to go ahead and read that. I also might want to see what access models I have, so I'll go ahead and read that as well. So read and write for those two things. And now I'll go ahead and do talk to Django video or something like that as far as the name is concerned. I'm going to go ahead and create this API key, and then I'll go ahead and do this puzzle. Now I'm going to go ahead and save my API key. I'll jump into my .env here, and I'll do OpenAI API key, set that equal to that string just like that as our API key. Now, mine is not going to be that in the long run, so what I'm actually going to do is probably delete it before this video is out. But the idea is we have access to these different data points now. And so going back into our model here, we should be able to bring in from decouple, we should be able to bring in config and then actually grab that API key. So we'll go ahead and say the API key client, we'll just do API key equals to config of the OpenAI API key, which is this right here, and run that. Now, if for some reason it actually doesn't work, I just probably need to refresh my access or my actual kernel. So I'm going to go ahead and refresh and run all, or restart and run all. Once we do that, I should now have my OpenAI client. Now, once again, the important part of this is that we are creating the embeddings. So first we're going to create the embeddings, and then we're going to go ahead and do our semantic search. But first, to create the embeddings, we could have used the sentence transformer, and we could have went through this process. But of course, the sentence transformer has smaller embeddings, which means it's not going to be nearly as accurate as OpenAI's in terms of the semantic search, but also in terms of your embedding in general. A bigger embedding is going to be more accurate, although it might cost a little bit more. And so the idea now is we have this client in here, so we actually want to create our embeddings for each one of our query sets. So the way we're going to do this is we're going to create a function called getEmbedding, and it's going to take in our text and then maybe a model of some kind, and then we're going to go ahead and run that creation itself inside of here. So the final text is actually going to be text.replace. We want to get rid of all of the new strings in here and just turn them into an empty string. And then we also want to strip out, or rather a space, not an empty string, but a space, and strip out all of the extra stuff around it. This will produce better embeddings. As soon as you have new lines on there, it causes issues with embeddings. This is coming directly from the OpenAI documentation for this. Next up, what we want to do is we're going to return back our client.embeddings.create, the input being equal to the text itself, and then the model is going to be equal to the model that we pass in. This is going to return back some data. We're going to get the 0th element here, and then we're going to get the embedding itself. All of these items come directly from the OpenAI documentation, which is something you're going to want to check to make sure that you are doing this correctly for whatever the current state of the art is. Now, the embedding model is actually right here. This is the model I want to use. And so I'm going to go ahead and actually import that model, and we're going to go ahead and grab it from our blog.models embedding model. It'd probably actually be better that this is a configuration item. So I will change that in just a moment. So the config is the embedding model, and I'll just go ahead and set our default being equal to this one right here. There we go. And now we've got our embedding model in here. Great. So let's go ahead and make sure we actually define that one. And the default is going to show up just like that. Okay, great. So now we need to actually create our embeddings for each object in here. So now I'll just go ahead and say for obj in QS, and we'll say if not obj.embedding, or rather, we will want to say if embedding is none. This is just how the vector databases work, as I'll show you in just a little bit. We'll go ahead and say obj.embedding equals to get embedding of the text. So the embedding itself could be related to the title, or what we could do is actually have obj.get the embedding text raw, or something along those lines. If we did something like that, that would mean then in here we could actually do a model method and return back what it is that we want on here in terms of our embeddings. So you can always change this in the future. Remember that the embedding itself will help us find the actual answers. So every once in a while, you might want to combine the titles in here as well, or maybe some other metadata just to make the search a little bit more robust in of itself. Okay, so with this in mind, this should actually create that embedding, and then we can do obj.save, and we can run this now. Okay, so I've got no get embedding raw, no surprise there. So I'll go ahead and return and run all cells and just run that, and this should actually give me my embeddings in here, which should be fairly straightforward. Next up in the admin, let's go ahead and just bring this in real quick. So from.models, we're going to import the blog post and just do admin.site.register of that blog post. This allows me to actually see it inside of Django itself. I can go into the blog post and I can see each one that's in here, and I can see there's embeddings. Now, of course, if you don't use the Django admin, you could always just go back into the Neon console, go into your tables, go into your blog posts, and see that there is an embedding field in there as well. And it has, all of them have data. Fantastic. Okay, so that is actually adding the embedding data. There's a lot of different ways on how we can think about doing this. We'll talk about those a little bit later. But the idea now is, how do we actually do a query of some kind? So going back into embeddings with ID, this is how we did our query. So I'll go ahead and do that same concept of this query, but now we're just going to go ahead and use the get embedding function for that query. Once again, it's doing the same sort of idea, but now it's giving us a query embedding. And so we're going to go ahead and run that. And the logical next step would be to do something like blog post.objects.filter embedding equals to the query embedding. Now, of course, there's not going to be a result here because, well, first of all, the actual database setting actually restarted. So I'm going to go ahead and restart all of this because I paused for a moment. But the idea being that if I actually have this filter coming through, I'm going to see it's nothing. There's nothing that's exactly this query. So is there something like is like type of thing in here? And of course, that's not a valid query either. So what we need to do is something just slightly different than this, and that is going to be using the cosine distance. So we're going to go ahead and do from Pgvector.Django. We're going to import the cosine distance in here. And so this cosine distance is what we need to annotate on our blog posts. So we're going to go ahead and do our query set is equal to blog post.objects.filter. Now we're going to go ahead and actually, before filter, we're going to go ahead and do annotate. And this is going to be distance equaling to the cosine distance of the embedding to the query embedding. And so this annotation is going to be the distance, the thing that is going to allow us to better understand this query. Okay, so that distance itself, let's actually just go ahead and order it by the reverse of distance. I'll explain these things in more detail very soon. So we'll go ahead and just do for QS, or rather for object in QS. We're going to go ahead and print out the obj.title and then obj.content. Actually, we'll just do obj.title and then distance. And so what we've got is an ordering based off of this distance. Now, the thing that is closer to 1 is actually further away in this case. So we actually want to take this a little bit further. Distance is not the actual field name that we want. What field name we do want is similarity, which is equal to 1 minus, there's something called f, the f function. So we'll go ahead and do from django.db.models. We're going to import f and also float field. If we need to use float field, actually, we'll leave it out for just a moment. And we'll just go ahead and use f and capital F. Inside of there, we're going to put in some parentheses. We're going to go ahead and use that distance field in here now. And then this is going to be obj.similarity. Okay. And so what is happening here is the distance is how different between the stored embedding is to the query embedding. Like how close are they actually? And so if we remember the actual title names or any of the query content, we can actually just test this assumption out by just changing what our query is to being something like the dog jumped over the cat. So we'll go ahead and actually use the actual data that we have stored in one of our queries. And now we can see this thing in action. This is now showing us that blog post 1 is exactly this exact same thing. So the distance is going to be 1, the similarity is 0, 0 being, or rather reverse that, the distance being 0, and the similarity being 1, as in 100%. So I can actually multiply that by 100, and now we get a percent itself as far as how similar these things are. And so the actual ordering should probably be by distance, and so the 0th one should be first and then go on, and then we can actually come in here and say up to like 2 items, and those are now our top queries for this particular query, or top results for this query. And there it is. That is semantic search with Django. Now, naturally, what we need to do is actually turn a lot of these things into their own services, their own functions, so we don't have to write this every single time in like our views or in our admin or whatever. So that's actually what we want to do next. So it's a lot more reusable than it currently is. But this is actually super nice because we now have this similarity clause in here using just the F function that takes this annotation in here and then brings it in. It's actually really, really nice. So there's a lot we can do with this one in terms of how our actual semantic search ends up working. This to me right here is a much better search engine than what you'd use otherwise. So if you stopped right here and just had this as your search engine, that would be great. That would actually work out really, really well. Now, I actually want to show you one other method for calculating embeddings as well as something other than this that you might want to consider also. Now we're going to take a look at how to do semantic search with multiple Django models. The way we do this is with a generic foreign key. The process isn't a whole lot different than what we currently have, and it's actually not something I'm going to continue to implement. The point is really just to show you how it's done in case you want to go that method. I want to keep things simple so the actual blog post model itself will be left untouched, but the same process still can work. So the idea here is back into our project. I'm going to go ahead and run Python and then manage.py, start app, and we're going to call it products. So this is really just to show this example. So I'm going to go ahead and actually copy all of my blog post model. We're going to paste it in here, and I'm just going to go to this product model itself, leaving all of these other things in here as well, except for the embedding model. That one, I'm going to move up, and we're going to call this class our embedding model. So it's going to be models.model, and it's going to take in that embedding field in there. Okay, so this is going to be a generic foreign key. Granted, we could actually have a embedding object as models.foreign key, and we could actually use it in a very similar fashion as this, and actually just have a direct foreign key on there. But this, of course, requires us to create that in advance. What we could do also is use something called a generic foreign key. So to use generic foreign keys, we come in and do from Django.contrib.contenttypes.fields. We import the generic foreign key field, and then from Django.contrib and then .content types .models, we import the content type model. And so to actually create our foreign key in here, what we do is we actually create our object ID, and it's going to be models.positive integer field here, and then we add in our content type being models.foreign key of the content type. And then we'll go ahead and do on delete equals to models.cascade. Or actually, we'll go ahead and say set null, and then null being true. And then finally, our content object being the generic foreign key of the content type and the object ID. Okay. So this is now going to be able to be used on any field whatsoever. And so then back into my products themselves, all I would do is I would bring in one more field, and that is going to be our generic relation field. So generic relation, and then I'd come in here, and this product now would have the generic relation of the embedding. We'll go ahead and call this our embedding obj equals to the generic relationship of the embedding model itself. Great. So very similar to a foreign key, but this actual embedding could be used in other places. Realistically, I wouldn't put these things next to each other, But of course, if you wanted to see this implemented, please let me know. But the idea being each one of our instances would have something like this. We would then create a brand new embedding for each one of them. In fact, we could actually see just a very basic example of this. Like I said before, the generic foreign key should probably be its own app, but this is more of a proof of concept than anything. So we'll go ahead and do products in here. We'll save that. We'll go ahead and run our migration. So Python manage.py make migrations, and then Python manage.py migrate. And then inside of my admin, I'm going to do from.models, import product and embedding. And then we'll just do admin.site.register, product, and the same thing with the embedding. Okay, so jumping into the Django admin, let's just take a look to make sure that those things are in there. Assuming the server is running, let's go ahead and make sure that it is. And looks like it had a problem with how I did the admin stuff, so let's go ahead and refresh it. There we go. So now we've got these products embeddings. I go ahead and add in an embedding. The point here is this is still the same embedding field, but now I can pick any of my content objects, right? So it's a really simple thing to do then, and then I can use that same sort of query on those embeddings. So let's just use an example embedding from our blog posts, for example, and just change this a little bit. So I'm going to just go into blog post 28. I'm going to grab the embedding here. We'll open up a new field for this, or a new window rather. I'm going to paste that embedding in. I'm going to grab that it's blog object 28. And then I'm going to go ahead and grab the blog post itself, and we'll go ahead and hit save. Okay. And so now into Semantic Search, I'll go ahead and just duplicate this one really quickly. Because again, this is just a proof of concept. And we'll go ahead and say, let's open this up. And I'll give this a 7. And we'll go ahead with generic foreign key. Okay, and then Python notebook. All right. And so there we go. And now instead of using the blog models, we'll use the product models and embedding. And I actually don't need any of those other things because I'm not going to do any of them. I'm only going to get the embedding queries themselves. We might need to bring in that get embedding again. I accidentally deleted that one. So let's go back into here. Grab this and right above here. And then grab the OpenAI stuff as well. Okay, so let's make sure we can do our query embedding here. And there it is. Great. And so now with this product, this generic embedding field here, now I can annotate that same thing. This time though, the object itself is the foreign key object. Now I can do something called content object, right? So grabbing the content object itself, whatever that might end up being. Now if I refresh in here, what I get is, of course, that single blog post that we just added, and we can always verify that with object.object.id or object.content.object.id. Those two should be the same. I run that now, and now I've got this blog post model. So I can do the same thing all over again. This is the reason I did this, is I can grab products here. Let's go ahead and create a new product. And we'll just go ahead and say random, not real product. And then put some gibberish, say can delete, say save. This is product 1, it looks like. Okay, so I'm going to go back into my embeddings here. I'm going to copy this embedding, same exact embedding, of course. I'm going to go ahead and add it again. Now I'll go ahead and do object ID of 1, and then grab our product here, save it. And then now that I've done that, I now have 2 objects with the same values. I can run this again. Now it's showing me blog post and then random not real product. And then we can actually get more information about this. So this embedding model now, this embedding table can now go across a bunch of different models themselves. So that's really nice about that generic idea itself. Now this is starting to get a little bit more advanced than what I really want to focus on for this series. But I wanted to show you this because this is probably the way you would go about doing it if you wanted to have a really robust search engine that went across your entire content set or any sort of content that you might end up having. And then each one can have its own unique get embedding text raw that would then be used in the services that will still create in a little bit that will still roughly work the same way. It's just using a different embedding model and using generic foreign keys altogether. So that's actually fairly straightforward. Now, there's another thing that you would probably want to do, and that is remembering the query embeddings. So adding one more step to this is adding another model to cache the queries and the embeddings that come from those queries, so that you don't have to continuously do the same embedding over and over and over again. There's a lot of different ways on how you could think about doing that. You could save it into your Postgres model. You could save it into Django caching. I actually like saving it into the Django Postgres model itself, like making a full model just for querying altogether. But again, a little bit outside the context of what we're trying to do in this series, but it is something worth thinking about at this point. This would be a good time to do it, because now going forward, we want to actually start working towards a RAG, so that not only are we doing semantic search, but we're also doing a structured query. So it's like how many times, or what is the most popular blog post or something like that. There's a lot of different options on how we go about that. So yeah, that's more advanced semantic search with generic foreign keys. Let me know if you want to see more of this in the comments below. Now we need to update our blog app so that it works outside of a notebook. The notebook shouldn't have to be run in order for embeddings to be created. So the way we're going to do this is jump into the blog. We're going to create services.py, and we want to actually create the OpenAI services, basically. So I'm going to come in here and bring in OpenAI and config, and then we're going to go ahead and get this started. Okay, so we've got our embedding model. What I also want to have in here is our embedding length. I'm going to put this in the services themselves, and so we'll go ahead and use something very similar to the embedding model and just put in the default of 1536, and we want to cast this as a integer. Okay, so recreate data. I'm going to go ahead and get rid of that one. But back into my model, I'm actually not going to use the product model anymore, although you could make a service that does this in more places than one. But to keep things simple, I'm just going to go ahead and create the model. Once again, I'll bring this note in here for later. What I want to do here is I want to go ahead and say from import services, and we want to use the embedding model from services.embedding length and model. I might actually not need the model at all inside of here, but I do need the embedding length because it's on my vector field itself. So I'll go ahead and comment the model itself out and get rid of these other comments as well. Great. Next up, what we want to do is we want to define something like get embedding. Okay, so we've already seen this one. The embedding itself was this command right here. Bring that in, and there we go. So naturally, we need our OpenAI client in here as well. So another one we're going to go ahead and bring in, which is as simple as going back into our notebook here and grabbing the OpenAI configuration, which is going to be changed slightly from here. And we'll go ahead and say OpenAI equals to that configuration key, just like that. Okay, so one thing that's important to note with both of the OpenAI keys and the embedding links is I have defaults for the ones that I'm going to use. But also in the OpenAI key example, I absolutely want to make sure that that's in here. Now that I'm using these embedding fields, I definitely want to make sure it's in here in my environment. Otherwise, errors should occur. So with that in mind, I'm going to go ahead and create env.sample for those of you who might be copying or forking this project sometime in the future. You would have to update those settings in there altogether. Okay, so with that in mind, I now have my client and my embedding. So back into my models here, I'm going to go ahead and create my embedding. To do this, I'm going to override the save method. Now, this is not the way I would necessarily do it in a massive production system. In a massive production system, what I would end up doing is creating the embedding asynchronously. I would use something like Celery to create the embeddings. And once again, in the massive one that has a lot of data that needs to do a lot of different searches, I would go through this embedding model. I'd use that generic foreign key. This makes it a lot more tricky to do what we need to do in this series, but I just wanted to mention that as you start to think about bringing this into production. So we're going to go ahead and do super.save and then args and keyword args. The embedding field itself can be just like this in production as well. The way we create those embeddings might not be like this in production is the point. Great. So now what I want to do is I want to go ahead and say if not self.embedding, or rather, we want to go ahead and say if embedding is none, then we're going to go ahead and say self.embedding equals to, well, we want to grab the text itself, so raw embedding and text equals to self.get embedding raw. Okay, and so we want to make sure this is not none. If this if is not none, then we'll go ahead and set that embedding with services dot get embedding for that embedding raw text. Great. Another thing I could do in here is I can actually make another field, and we'll just call it underscore content, and we'll go ahead and say blank equals to true and null equals to true. And basically, we want to see if it's changed. So if self.underscore content is not equal to self.content, then has changed being true. Otherwise, has changed is false. So basically, if it's none, then we're going to run that. Or if it is true, then we'll run that. And this is probably equals, not is. We can do that in a second. But the idea being that we have this content in here now. So let's go ahead and run our migration. So Python manage.py, make migrations. And then Python manage.py, migrate. So let's see if that actually creates our embedding inside of the admin. So we'll jump into the admin now. I'm going to go ahead and go into my blog posts here. And we'll go ahead and do new blog post. And we'll go ahead and say hello world. Save and continue. And there's my embedding. Hello world again. I'm going to go ahead and copy this and just put a temporary file here. Actually changing this is, or seeing if it changes is going to be a little tricky. So instead of seeing if it changes, I'm just going to go ahead and say now I'm going to just let it be equal to just none for just the moment, just to make sure that it has changed. We could also print it out if we wanted to. But hello world again, everything's all saved up. So we can come in here, hit save and continue. And now we got none. Great. And so if I bring it back, it would actually come back. Save and continue. Now it's going to create that embedding. In theory, it would. And I have one mistake in here, and that is self.content should equal to that. This extra field in here is just to basically know whether or not that field has changed from the previous iteration. There's other ways on how you could think about doing this, but this is a simple way to do it just by having another field that they compare each other. You could also just do something called force recreate, or you could just recreate these embeddings on like a regular basis when things are saved in some form. Okay, so now that we've got this, we are a little bit closer to having just that semantic search in place. But the thing is, I actually want to have a service for it. So that's actually what we'll do now, and that's going to be defined, and we'll do our search posts, and it's going to be self and query, or rather not self, but just query. Okay, and then we're going to return something. We're going to return a result. So one of the things that we can't do now is do from.models import the blog post. This is a circular import. It will actually cause an error here because the model is importing the services. We can't import each other like this. So we have to do something just slightly different, and that's from Django.apps, import apps. And now inside of this search post here, we can do blog post equals to apps.getModel. And then we pass in the name of the model. So we do app label being blog, and then the model name being our blog post. And there we go. So now we can actually use that model again. So going back into our semantic search, what we ended up doing was this query set right here. All right, so I'm going to come in here, bring that query set in. We will bring these imports and put them above. So let's go ahead and grab that and put it right there. And there we go. Next up, we've got our query set here. We need to get our query embedding. So this is where I'm going to define get query embedding, and it's going to take in a text. This is where we're going to do a get or create to a query embedding model. If we wanted to track those things, this is where I would do that, which is exactly why I have it here. But in this case, I'm just going to go ahead and return get embedding of the text itself and not really change anything other than that. And so now my query embedding is equal to get query embedding for the query itself. And there we go. So now we've got our queries in here, and I can quite literally resort this by QS. Now we could do it based off of the distance, or we could do it based off of just the query set itself, the similarity. Either one, it doesn't matter. Whichever one you use, it needs to basically be the opposite. And so the similarity I'm going to leave as a decimal place, and then the actual limit I'm going to go ahead and put up here being like 5. So limit the search results to 5. Maybe 10, maybe 15, but you can change that as you see fit. There we go. So now I just need to test this out. So going back into Jupyter, I'm going to go ahead and duplicate. Let's go ahead and duplicate 6 and open this up. Now we're going to go ahead and do our services for search and something like that. There we go. Initialize Django. We're going to go ahead and go from our blog, import services. And then I actually probably shouldn't need any of these things in here. So we'll go ahead and give our results equals to services dot search posts. And this is amazing. We've got services is not defined. Oh yeah, we should probably define it. There's our results. And then we can do the similarity. Now, the other thing I might actually want to do is call this rank or something like that. But let's just get results.first and similarity. There we go. So not a very strong match, but a match nonetheless. Let's do a high-level overview of what's going on with this cosine distance. And it's all thanks to this guy right here. His name is Vector, and he has both direction and magnitude. Of course, that's from Despicable Me, but the idea is still there. Direction and magnitude. Here is an actual example of vectors. They have direction and they have a size or a magnitude of some kind that can be used and be calculated. So what we want to do is we want to be able to have a formula to actually calculate these things. That formula is actually the cosine distance. So what we want to see is how to actually use that formula, how it's done on a very simple scale, because then it can be scaled up to a lot more robust things like our embeddings. Now, if you're not aware at this point, our embeddings are vectors. They're their own vectors. They're stored with Pgvector for a reason, because they are all vectors. They have direction and magnitude. Although they are more complex than these three right here, they are still vectors. Now, we use Numpy because it's an efficient way to do, well, linear algebra in Python, as well as other math. But linear algebra is how we actually calculate these things. So we're going to go ahead and import Numpy, and we're going to create these three vectors here. Now, just at a glance, we can already tell which ones are similar and which ones are not. I don't need to chart it. I can just look at the numbers and be like, oh, okay, A and B are very similar. C is the oddball out, although it's not that much different because of the two, right? So let's see how different they actually are. And so we come in here, we can see the shape of these. These all have 3 items in there. We could try that with each one. To calculate the magnitude of any given vector, we square each item in here, so 1, 2, 3. Then we add up those squares, and then we take the square root of all of those squares. What this does is normalize it so they're all basically the same direction. They're not actually the same direction, but that's the idea. Because if you square each number, it's going to give us the positive value of that, and then we get the square root. That gives us that magnitude. So, of course, we can do this in pure Python itself, or we can use Numpy to do it, which, of course, is the recommended way to do big calculations like this. And we can actually create the magnitude for all 3 of these arrays. And we can already see that array A, or vector A, array, and vector are the same in this case. But vector A and vector B are basically the same. We can already see that with their magnitudes. Vector C is very, very similar. Not quite there, though. Okay. So now, to actually calculate how similar they are, we do the dot product of these two things, basically multiplying the vectors together and then dividing it by these magnitudes to get a similarity, in which we get very similar for the first two, not so similar for the A and C, right? So A and B are very similar, A and C are not very similar. And of course, you could do the same idea and compare B, and C if you wanted to. But this same thing is true for our actual embeddings. So here's an embedding example right here. It is massive. There's just a lot of data to it, as you can see. This embedding in particular came from a blog post item that I grabbed. I just copied this, brought it into my notebook, and then just turned it into an MP array or a vector itself. And we can see the magnitude on this one. It is much closer to 1, which is really interesting. Now, the bigger the embedding, the more accurate the similar comparison is going to end up being. When they're smaller, well, the accuracy goes down. And that is, of course, for the text itself, right? Because the text is nuanced. The embeddings are based off of the position of the text, the way you're writing things, right? So, hello world again is much different than again, hello world. This is a much different vector. They're very, very similar, but much different. And once we have a lot of content in there, that embedding will probably have to grow. That's why if we think of OpenAI, the way it actually did the vectors themselves, right? So going back into our services here, we had these embeddings here. The latest state-of-the-art embedding is much bigger than this. It's a much bigger vector. It's a bigger length because it gives us a lot more granularity in terms of how it's compared, both because of the magnitude, but also because of the dot products and how accurate these similarities can end up getting. And so what ends up happening inside of our database is something like this. In Cosine, it creates those cosine metrics, as in the similarity and distance. Well, in our case, it was just distance. That's all was being created here. So there's the distance there. It's taking the field of embedding and comparing it against this other embedding on each one. Each field is happening. And then we just use similarity. We just did 1 minus that distance. As you can see, these things can be inverted of each other, which is 1 minus on either one. And then you can get the values they come through. And this gives us the similarity. In this case, I just multiplied each one by 100 and rounded it to the nearest number. But this gives us that similar vectors in there. And so this last vector is identical to this one. So if we were to change it a little bit, we can see the values come through as to what's going on. And of course, if we change the numbers even more, we can also see even greater of changes and how similar or not similar a lot of these things end up being, which is also really compelling and a way to just calculate, the distance and the similarity coming first, distance coming second, right? So it's actually pretty cool. It's actually a really simple way to calculate these distances. The complex part is actually calculating accurate embeddings. So these will continue to improve over time. The cosine distance isn't going to change. This is a mathematical formula that has been really well figured out for a long time. The reason I wanted to show you this was not to give you insight into how to do linear algebra per se, or necessarily convince you that you should learn it, but really just understand that at the end of the day, it's just math that's happening under the hood. And it's actually not that complicated of math. While it might be complicated to do it with major embeddings by hand, it's not that complicated to do it when you start using tools like Numpy. So yeah, if you have questions on this, let me know. If you want to see more, or if you want to see how we could do like our own embeddings, building them out by scratch using maybe Numpy and a few other things, please let me know. That is incredibly technical and probably outside the scope of something a lot of people might want to use, because this is all about practicality. We want to make our search posts as practical as possible, and to extend this a little bit more is to implement something like RAG to actually be able to use different kinds of queries than just semantic search like this. Semantic search is a great way to query our database and query for results that are similar. It's not going to actually infer those results. It's just going to look for things that are similar, as we've already seen. Now, what it's not going to do is it's not going to answer questions like, what are my most popular blog posts? Now, there's a way to probably hack semantic search together to make that sort of work, but it's not really going to do that. So what we need instead is a way to turn a question like, what are my most popular blog posts, into a SQL query that could then do aggregations and all the things in SQL as necessary, then infer the responses from that. So even something like ChatGPT can't really infer this answer. It can infer to a degree, but it knows that it doesn't have access to our specific analytics. So for that reason, we need something different. We need to actually combine the idea of an LLM like ChatGPT with the idea of semantic search and also using just raw SQL. And to do this, we use something called Retrieval Augmented Generation, or RAG. I don't really love the name, but the idea is you can just give some natural query, and then it's going to use to its best ability to find different resources to respond to that. Some of those resources might be like a semantic search. Some of those resources might be a SQL query. But at the end of the day, it's going to help infer from those resources what it should give back, what it should respond with. Like, instead of saying I don't have access to your blog analytics, it will say, oh, your most popular blog is the dog jumped over the cat because it has 10 views. It's going to respond exactly like that, or very similar to that, because of the LLM aspect of it all. And so that's actually what we want to work towards. And the way we're going to do that is by using Llama Index. So with Llama Index, we actually have to re-engineer some of the semantic search using Llama Index itself. But the reason I didn't do that yet is because the way we have semantic search working right now is effective for a lot of different queries, whether or not you want to have them in a RAG pipeline or not. And we can still use all of the data to some degree with what we did in semantic search in the first place. As in, we can reuse all of those embeddings right inside of Llama Index and the Llama Index Postgres vector store. So this is definitely a hands-on process to make all of this work, because there's a lot of different nuances on how Llama Index works it, and of course things will probably change over time. But overall, what we need to do is we need to start with creating a semantic search in Llama Index. Then from that semantic search, we're going to go ahead and create a text to SQL query, which is a lot easier actually. And then we're going to go ahead and combine the two of them and just make it all work really well. So let's go ahead and get started by opening up a brand new Jupyter notebook. Go ahead and create new, and there's going to be 10, and there's going to be Django to Llama Index, probably like part 1. Okay, so the idea, of course, is import setup, and then setup.init Django. Great. Now, what do we need? The very first things that we'll need are things related to what we did before. So that's going to be our blog post, our embedding length, our services, our configuration, all of that. So I want my query set, of course, being blog post.objects.filter, and this is going to be can delete being true. Right now, this query set is really small, but I want to make sure that I have access to it because we will be using this again in just a little bit. Next up, what I want to do is some installations here. So I'm actually going to put these installations in line to the Jupyter Notebook before I put them into my requirements, mostly so that I have them going forward. So the first thing is Llama Index. Next is the SQL Alchemy package, which is kind of funny given that we're using Django, but Llama Index uses SQL Alchemy for a good reason, as we'll see. Then we bring in the Llama Index vector stores for Postgres. All three of these installations may change over time. They definitely have changed from the past, so keep that in mind when you try and diagnose any errors related to what we're doing here. So after you do that installation, it might take a little bit before it does. Then we're going to go ahead and bring in some of our default configurations here. So the default configurations are going to be related to pretty much everything we've already done. So the LLM model, this model itself, we are not in use yet, but I do want to bring it in just so I can use it at some point. The embedding length, notice I actually do import it in here as well. You can use the configuration variable either way, whichever one you want to do it. The embedding model, once again, is coming from environment variables and our OpenAI key. And then we implement the OpenAI class as well as the OpenAI embedding. Now, to implement those classes, we need to import them. So we're going to go ahead and do from llama index.llms.openai. We're going to import the OpenAI class. Now, of course, this is a lot like the OpenAI class itself directly from OpenAI, but I think it's slightly different specifically for Llama Index. And so if for some reason it's not installing, just take a look at how you can go ahead and install that. The next one is going to be our OpenAI embeddings. This, again, is another class that's just using that. And I pass in the OpenAI keys directly to these instances because after we have all of that figured out and set up, what we've got is we want to override the default settings inside of Llama Index for the LLM and embedding models. These things can change. You can use a different LLM. You can use different OpenAI embeddings. This doesn't have the same implications as it would inside of your pre-existing models, right? So if you were to change the embedding length or the embedding that you end up using, the actual model, you probably want to do it globally on your whole system. But with Llama Index, you don't necessarily have to. You can make changes. How we're doing it, you would have to, but you'll see, just generally speaking, how you could change it, and we'll talk about that when we get there. But now that we've got these, we want to update our settings here from our Llama Index, which is going to be llamaindex.core settings, and then we just set settings.llm equaling to this LLM class here, and then settings.embed model equaling to this embed model right here. So that changes it for all future calls to Llama Index. That's really important because we don't have to repass these things anywhere. This is the current way to do the setting. It did change. It used to be a little bit different, but now I think this actually makes a lot of sense in terms of how we want to go about using this. Great. So the next thing is we are actually going to create a specific database inside of our Postgres database for this. So as you can see, I already have examples in here. It's called VectorDB. And then I've got this table that's already in here, which in my case, I'm going to go ahead and drop. Now, you can actually see these tables by going into tables here and then grabbing the different tables that you've got. So the default one is that NeonDB, which is our Django project. And then VectorDB is the one we still need to create. So let's go ahead and bring in that name and also the DB table name that we'll end up using, which actually gets turned into data underscore and then whatever that name is. That's what it actually gets turned into with Llama Index, as we'll see also. So the next one is going to be our database URL. Now, this is actually going to be a little bit different than what we've already used because we want to use pooling. So we're going to go ahead and come in here and do something like this. Now, we want to use pooling, which means going back into Neon, into our dashboard here. We're going to go ahead and toggle this pooled connection. I'm going to go ahead and copy it. And then I'm going to go into my .env file, and I'm going to have this database URL pool, and I'm going to go ahead and paste this in. This is basically the exact same thing as our database URL, but using the pool, we'll have these pooled connections, and it's a lot more effective for Llama Index. So that's what we're going to end up using. So going back into our notebook here, then we want to change this to database URL underscore pool. That's it. Okay. So with this in mind, in order to be able to use SQL Alchemy, we actually have to change this database URL a little bit and basically add Postgres SQL in front of it, just like that. So this is how I do it. I'm going to go ahead and restart the kernel and go ahead and make sure that this is running with the database pool, because in theory, if you followed along, you would actually have added this. Oops, I'm in the wrong spot. That's curious. What happened here? Let's go back. I don't know how that happened. Okay, so let's close that one out. And here we go. Not sure why that one's open, but there we go. So back to where we're supposed to be. Let's go ahead and restart all cells here and just make sure that we've got everything set up with the database pool and all that. There we go. Okay, so now after we do this, we now need to create a new database. Okay. So the reason we have to create a new database is because we're going to go ahead and use Llama Index to store the data in this new database. This also means that you actually don't have to have these next to each other. In other words, you can have your Django project on its own project, and then you have your VectorDB on a completely different one. I'm going to leave it in one place because it's pretty simple and efficient to do so, but you could always have it in different places if you need to, which is why another reason to use this database URL pool to just have it as a different place altogether. So the way we're going to create this, I'm just going to go ahead and copy and paste some SQL Alchemy code here. This is actually fairly straightforward. We grab our Postgres database, we use create engine, we actually take a look to see if it already exists, and if it does not exist, we go ahead and create it. We also want to make sure that the extension is coming through from Pgvector. This, of course, comes directly from their docs as well for SQL Alchemy. There it is right there. We probably don't need to do that, but I am going to go ahead and run that and just make sure that our database is actually created for us. In my case, it was already created. I did it off the video, but this is actually fairly straightforward SQL Alchemy, creating database command, essentially. Okay, so now is the next part, is actually using our Postgres PG store, the Pgvector store that we've got. So what we want to do in here is I'm going to go ahead and take a look at how they have it all connected. Oh, here's a create database one right there. Interesting. It already actually has one in their documentation. So we're going to go ahead and use this part of their documentation as well. So I'm going to go ahead and copy this. We're going to bring it in and paste it in here. Okay. So naturally, the URL connection string is, well, this database URL. The database name is actually, we called it our vector database name here. And then we've got all these other things. The table name is not Polygram Essay, but rather the one that we have. Then our embedding dimensions. What I want to use is my embedding length. Now, obviously, it's using the default one, but if I need to change it at any time, that's how I can go about doing that. Okay, so now we're going to go ahead and run this just to make sure that it's all working, and it is not. So I need to bring in the imports for it, which the import for it is simply that one, which is also in the documentation as well. Let's go ahead and make sure that we can run that. Looks like it runs just fine. Great. So now we have the next step, which is going to be creating out our index or grabbing our index value, which is going to be from llamaindex.core and all of that. So this query engine, this is how we're actually going to be able to search everything. But what we see right here is it's saying from documents. That's actually not what we want. We don't want to do from documents in this way. I want to do it a little bit differently. I want to do it from pre-existing data in my database. So I'm actually going to create these documents just slightly different. So the way this is going to happen then is our index is not going to be from documents. Instead, it's going to be from vector store, and it's going to take in this vector store lookup, and then it's going to go ahead and pass in our storage context in here as well. So just slightly different from our database, but this is a way to reuse it. Instead of trying to create those documents every single time, this is how you can reuse it. So this right here, or well, actually these two cells would be how you would use it in Django otherwise. So now we can use our query engine to query something like my query, and what it should give us is basically nothing back, right? So we've got invalid port value here. Okay, so the components port, see that it says port in here. Now the reason for that has to do with this URL, and so all I want to do is use the default 5432, which you can actually get from Neon itself. So if you go into the dashboard here, go into the connection string for, let's say, Django, for example, you can see that it looks for the PG port or 5432, the default one. So that's what we do, because the connection string just doesn't have that port in it in this case. So once again, I'll go ahead and run that again. And now it actually can connect to that database and we get an empty response. No surprise here, we don't actually have any data in here yet. So we need to actually create some data, and that's something we'll do in the next part. Off the video, I noticed this weird import error that's happening inside of my migrations files. So this import error doesn't make a whole lot of sense to me. And so the way I solved it was by going into models.py, and I see this is actually where I imported the vector field, but the error is saying that there's pgvector.django.vector. Have no idea where that came from, but that of course is not the correct import. So I want to go ahead and change it where I see the error happening. So the first one is inside the blog itself. It says, this is the import. That's the correct import. So that one's correct. The next one was the incorrect one, the actual embedding when I brought in that field. So I just get rid of this dot vector here and this dot vector here. Now it's the correct field or the correct location. And then I see that it happens again in another one. So let's go ahead and make sure we save that. And the other one is in the products model in the initial. For some reason, once again, it has that dot vector in there, which is not correct in terms of the code whatsoever. And so there's a couple different ways on how you can solve this. You can go to the definition of the Django stuff. What we've got here is the init file. There is no vector module in here whatsoever. You know, perhaps there was at one point, or perhaps there's some syntax error. Not sure why that happened, but that's not important anymore because we just solved it. And of course, if that comes up again, just go ahead and let them know on Pgvector Python as far as an issue is concerned. Now, with that out of the way, let's go ahead and pick up where we left off, which this, of course, was the Django to Llama Index. We're still doing the semantic search stuff. But at this point, we can connect to a brand new database and a new table inside of our Neon project, right? So it's important to note that this database itself is not the same one as our Django one. Although we have vectors in our Django one, we have a new database altogether for Llama Index. So this presents a new challenge that's not necessarily going to be common in Llama Index from their perspective, but it might be common from yours. You might not use Llama Index for a while, so we need to be able to address that. We need to be able to see how we can actually add in our own embeddings into their vector database table, or the one that Llama Index manages. So the way this is going to be done is by going into the Postgres vector store. We can see exactly how to start a brand new one from scratch with data they provide. But we have our own data that we want to provide, so we need to do something different than this example here, but it's only slightly different in the sense that how we actually load in the documents. As we see here, we download some documents. That's the way they call inserting in data into the database. They call it documents, so each row is a document. The idea here is we load in some documents into our index. This is starting from scratch. We aren't starting from scratch. We need to do it a little bit different than this. The way we do that is by creating our own documents, and it's actually very straightforward. So in our case, we're going to go ahead and import the document class itself, and then we're just going to iterate over our blog and actually insert documents that way. So let's go ahead and grab this, and I'll bring it in here. There's our document. And so what we want, of course, is all of our blog posts, which are right here. So I'll just go ahead and query those. And in our case, we'll do objects.filter and can delete being true, right? So really just the objects that are meant only for these Jupyter notebooks. And then we can actually print out what that query set would end up being. And there it is. So we actually want to use this document class, and the way, at least at the baseline level, the way we create a document in here is by doing document and then text equals to some text. That is the minimum of what you'll need inside of your vector index itself. So let's take a look at what that ends up doing. So I'll go ahead and say docs equals to an empty list here, and then I'll do the docs.append of this document with the text we want to add here. So whatever text we pass in here will be turned into an embedding. At least it will be at this point, right? So we're going to go ahead and add in our own text. We'll go ahead and do fstring to use the object itself. Now, the object had a method that we specifically made for our embedding. So if we go into our blog, into models, we have a method here called getEmbeddingTextRaw. This is what I'm going to use. Now, you could use .content, or you could use this method here to change it as you see fit. I like using this method, as I mentioned before, because we can enrich it with all sorts of data as we see fit. So that's the text that I want to add in, and then we're just going to go ahead and do, we'll print out what those docs are. We'll take a look at those docs by running through here. Here's those documents. Notice that they have their own unique ID. If I were to run this again, that ID changes. This is an important distinction, as something we'll see very, very soon. But the idea is now we have a bunch of documents ready. So how do we actually insert them? Now, if we were doing this from scratch from the very beginning, we have this big database that we want to just load up. You could do this index from documents. That would still work in this context. You would just pass in our docs, list here instead of documents, and that would actually create it for us. In our case, though, what we want to do is we actually want to use index.insert a doc. So we're actually going to go ahead and iterate through each document here. So we'll go ahead and do for doc in docs. Then we'll go ahead and insert this docs. There's a reason I'm iterating here, which we'll see soon enough, but I'm going to go ahead and run this. And so what's going to happen here is it's going to attempt to run various things related to our connection here. So right now I'm getting a SSL. Not sure what this error is, so I'm going to go ahead and restart the kernel and run all cells again. Perhaps I just need to refresh my session overall because it was just pending for a while. So let's go ahead and rerun it and see what ends up happening here. And now it actually does insert it. So I just need to refresh my session. No big deal. Okay, so now if I go into Neon, I can actually take a look at this table. And let's go ahead and refresh this one. And we see now those documents coming through. Now, if I run this again, what do you think is going to happen? Well, it's going to happen in a way that you may or may not want to have happen, and that is it's just going to go ahead and add them in again. So that's not what we want to have happen. There's a lot of different ways on how we can approach that from not happening. The first way is the document ID. We actually want to change the document ID to be slightly different than this, and we actually want it to be based off of our blog posts. So the way we do this is by passing in our own doc ID, and we put it into a string, and I'll just do object.id. So it has to be a string. That's just how it's treated. I mean, these are UUIDs, but they are treated as a string in here. And so if I were to run this again, I now see my IDs in there. I can now go ahead and insert in those IDs once again. So if I refresh in here, granted it did add all of these things in once again, but the thing is now, if I were to add it again or run it again, it would actually add them again. So it's not quite there still. So what we do instead is we just delete the old document and then insert the new one. This is a way to kind of update it. Now, there's probably a more elegant way to update it altogether, but the fact that we are adding a change to this particular document, which would sort of imply that there was a change to the blog post, there's no problem deleting the old entry because, well, this is not the actual database table. It does not the actual database table for the actual data that we're using. It's only the database table for basically querying this database or this data. So in other words, we can go ahead and do index.delete _ref doc. And this is where we can actually pass in the doc.id underscore. Notice that it has an ID and underscore here. And we're going to pass it in as a string. So that's just a quick way to delete it. And then we'll go ahead and also do another argument called delete from doc store being true. Okay. So if I went ahead and ran this with these quotes in the right place, I could actually go through and delete everything. Now, unfortunately, at this point, I already have a bunch of these documents in here. I did delete some of the ones that are matching, but I actually want all of these records gone. So I'll go ahead and delete them right inside of Neon, and then we'll go ahead and run this again. And so now it's going to go ahead and actually create that as we see fit right here. So if I were to refresh in here, there it goes. It's all in there. Let's go ahead and run it again. And what we'll end up seeing is hopefully we'll only see 4 entries again. So if I refresh in here, looks like my notebook is done. Same entries. So now we can verify that these documents are directly correlated to a blog post object, which is fascinating or really nice. Now we can actually query these documents as in, let's say, the dog jumped. Run that query engine. There we go. We get a response. So we can just go ahead and say response equals to that. And then we can get the response.response, or really the string of it. And we can take a look at what that is. So let's go ahead and run those two. And there we go. The dog jumped over the cat. That is the blog post. Now, that is nice, but it's missing something that we'll talk about in a moment, which is really that ranking. But in terms of the semantic querying, this actually works out really, really nice. It gives us exactly what we were looking for in terms of the query and the content of this data, which is all we're feeding in. Now, we can add more things into this document, as you probably would want to, which is like the metadata in here. You can pass in metadata, as in like the primary key or the ID. I'll just use primary key. So obj.pk, and then the title being the, obj.title. And so this metadata is just one more field that you can add that is data beyond what you need to be embedded. This is not any different than what we've already done with our own models, right? This is very similar. It's just in a different place. That's it. And so now I'm going to go ahead and run that again. And this time it gives me this response. Let's actually just look at the response again. And so now we should actually be able to see that there's metadata in here. So if I do response.metadata and hit enter, I now see a couple matching items that go in here. But the idea being that we now see different blog posts that actually match this. So it's a lot closer to even our own queries in terms of getting a primary key itself. So that's actually really nice. We will continue to go back to this, but overall, in terms of semantic search, this is exactly where we might want to be going from, right? And so getting those primary keys would be just a matter of doing, .key, or rather .keys. So we've got our keys in here. So we'll go ahead and say something like for key in those keys. Then we will grab the metadata and that key there. And then we're going to go ahead and do for, let's say K value, or let's do sub K value in those items. We'll go ahead and print out sub k and value. And we'll go ahead and make sure we do dot items here like that. And there we go. So now we can see the primary key and the titles and all that. So you'd be able to actually grab those values as you see fit. Obviously, these are nested dictionaries. But overall, the idea being that we can now query the database a little bit differently. But there's still another key aspect of this that we want to actually understand. And that is what's happening with these embeddings. Right? So there is embeddings being generated, and they're being generated every single time. But we actually already have embeddings in our original database for that original model. So we have embeddings right here. How do we actually combine those things and then verify that as well before we move on to much different? So now all we need to do is verify and add embeddings on our own, and we'll do that in the next part. Now, in terms of RAG, we could probably just stick with this query engine and start implementing the RAG side. But in terms of our embeddings, we already looked at that. We already saw how we could do it. So now we need to actually update this functionality a little bit so that our document actually includes the embedding. We'll see how that's done in just a moment. But before I actually include anything, I actually want to verify the embedding itself. And the way we're going to do this is by querying the new database. So the new database itself is going to look something like this. The actual new database URL is going to be a Postgres URL, and then all of the things I broke down in this make URL function here, which grabs the host, the password, the port, the username, and then we use the vector table name, this different database name, which of course is different than the one that we are using for our Django project, which has the database name at the very end, as you can see right there. And the vector database has the URL pool, which is pretty interesting that that's in there. That was probably just a typo. But overall, what we've got here is now our database URL that we're going to end up using for this one going forward. So what I want to do then is I want to go ahead and actually import a couple things related to that. That is SQL Alchemy. We're going to create a SQL Alchemy engine. This is all verification. You don't necessarily have to do this, but I do want to verify it before I start actually implementing the docs themselves. So we're going to go ahead and create the SQL Alchemy engine. This is going to allow us to do a connection to it. Very similar to what happens up here. This is actually creating the connection for us from SQL Alchemy. This right here allows us to perform our own queries in here for our SQL Alchemy engine. So what we want to do is I actually want to get all of the different rows that are in there. And so the way we do this is we use engine connect as connection. We add in some queries here, and then we add in the data that we want from the tables themselves. We run that query, and then we get our results. If I were to run this now, I get this error of URL does not exist. That's probably because I haven't run this whole thing yet. So I'm going to go ahead and run that whole thing because this is a new document. And what we'll end up seeing is a number of rows that actually match this. These are the exact rows that are in the database itself. And so we can actually iterate through these. We can do for row in rows. We could print out the order that we selected things. So the first one is going to be the metadata. The second one is going to be the embedding. And then we can actually just go ahead and say row 0 and then row 1. And then I can print out the embedding. Now, the reason I'm printing out the embedding has to do with the fact that, oh, cool, the embedding is actually in here. And so I want to compare what's stored in the vector database to what's stored in my Django Neon database, right? I want to compare those vectors. And you might recall we have a way to compare those vectors. The way that's done is the cosine metrics, right? So calculating cosine metrics. So I actually want to compare two vectors. This is how you do it. So this is how you do it with the way these vectors are created as well. So let's go ahead and grab the IDs then. So I'm going to go ahead and get my metadata. We'll print out what that metadata is now instead. I'm going to go ahead and run this. This gives me my primary key. So now I can say the blog, post pk equals to the metadata.get of that primary key. And then this, of course, will give me the option to do object equals to blog post objects.get, and then the ID being that ID. Or really, we could do primary key in case you have a different primary key in a different ID field, which you probably won't, but the idea being that we can actually grab that data, and then I can print out that object.embedding, right? Great, and so, of course, I want to actually compare this to my other embedding, the one that's stored in the other table or the other database. I'm going to go ahead and print that one out as well. And of course, the comparison itself needs to be done with the calculate cosine metrics. So the first thing that I want to do is I want to convert this embedding to a NumPy array to ensure that it is a NumPy array. So the way I'm going to do this is by doing np, let's go ahead and do embedding array equals to np.array of the embedding itself. And I just want to verify the shape of it as soon as I do that. So we'll do .shape and we'll run this. I'll get rid of this metadata print statement here. And we're getting an empty shape, which is kind of strange here. I also probably want to declare the data type. So dtype being a float and just running that. And we get this error. It says cannot convert string to a float. So right now the embedding array is being treated as a string. So we need to change that. The way we change it is by stripping out the brackets at the beginning and the end of any given item, and then separate out all of the other items in there. This is basically saying we just do dot, strip the brackets. So we'll put the brackets in here. Then we'll do dot split of the commas, and then that should actually turn all of this back into an array. So I should be able to run this, and now it is a proper array. And now I'll go ahead and do obj embedding array, or the objects embedding array, which will still be numpy.array, and then obj.embedding, and then the dtype also being the float. Okay, and we'll go ahead and do this one as well as a shape, just to make sure they're the same shape. Overall, they're the same shape. There's no surprise to the shape part, right? The reason they're the same shape is because they are using the same exact embedding model. There's a possibility that they're not using the same embedding model, which is one of the benefits of having these things separated if you want to use them separately. But obviously what I want to do is calculate these cosine metrics here. So I'll go ahead and run that cell here and then just print out that calculation, run this, and all of them should look exactly like this. 100% similarity and 0% distance, because they should be the exact same values all around. So this brings in our next part is like, well, what's happening within our documents right here, when we insert them into the index, the embedding is being created for us. So what we could do is we could actually create the embedding on our own. We don't actually have to do it this way. So the way I'm going to do this is come back into my document here, and I'll just go ahead and pass in an embedding argument here for obj.embedding. Like that, hit enter. I'm going to get an error that's saying that it has to be a valid list. So right now it's stored as a NumPy array. So all we need to do is .toList, just like that. Now it's going to go ahead and create those documents for me. And then after they're created, we need to go ahead and insert them in, which is right here. So we run through that. I'm going to go ahead and comment this part out. So now we're providing those embeddings, so the actual results should basically be the same. There shouldn't be any difference in here with the results because we are now providing those embeddings, but also the fact is that we don't need to regenerate them. So when we regenerate them, like we were doing before we actually passed in the embeddings, we are getting charged twice for the same embeddings. We don't need to do that. We don't need to do the embeddings whatsoever. And so this brings me to the next part of like actually doing custom embeddings, having our own custom embedding class that we'll end up using for our actual model itself. So that's this class right here. We've got our embed model here. I'm going to go ahead and create a new version of it, and I'll just go ahead and say class my OpenAI embedding. And we're just going to go ahead and customize this here. And then I'll go ahead and say pass to start out. And we'll go ahead and put our embed model now being that our custom one, right? And so what we could do in here is actually redeclare a lot of the different methods that are happening inside of this model itself. Now, the way you find what those methods are is going to be fairly straightforward. You grab this, you go into VS Code, you open up a new tab here, and then you go ahead and actually go to the definition of that file, and then you can actually see all of the different methods that are in here. So what we want to look for is define get and then things related to get. So there's the get query embedding. As you can see, it's in the OpenAI embedding class. So I can copy this one and I can bring this on over in here as well. Now the default, we could just go ahead and say what the default would end up being, which is return super dot get this a query embedding of that query. So passing in the original. And then we can actually just print out what that query is. So we can just say my query and then just say query, right? And so I could keep going down the same logic by getting some of the other ones. There's the get text embedding one. So I'll go ahead and bring this in as well. And I'll still just use the super call in just a moment. But there's also get text embeddings. So if there's a list of embeddings, we can take a look at that one as well. Now, all this is to say is we can actually change how these functions end up working for when we actually are generating those embeddings. So if we wanted to use our own embedding class or our own embedding function in multiple places, this is where we'd be able to do it. So if we go back into our blog itself, right now we have the services of, get embedding. We could still use that same one, and this is just a way to show you how that would be done. And so in here, once again, we would just say our super call, so return and super dot all of this, and just get rid of that self item there and pass in that text. And I'll go ahead and return that same thing down here. And let's bring this tab back a little bit. And this one is now texts and that. Okay, great. So I'm going to go ahead and print out the texts. I'm going to print out each one of these. This is actually going to verify that we have our embeddings either being created or not being created. That's really the key as to why I'm putting these in here. Yes, you can customize them, but really we want to know whether or not these things are being created for us. And I'm getting a print statement indentation problem. That's this string right here. And then we got list is not defined. So let's go ahead and bring that in. That's from typing import list, because we have types in there. So there we go. Okay, so now we've got our new embed model, which we can run through and just use this. We can see in our query, it should say my query, and it does, right? So it actually did that print statement right there. So once again, we could store the query embedding, and then we could reuse it in here. So we could do something like a, let's say if we had a query model, we could do objects.get or create, query being query. And we could save the embedding in there, and we can also then return back what that embedding would end up being. So if we went along these logic, we would say something like this, where then it'd be obj.get query embedding, like that. And that's what we would end up returning. Obviously, I don't have that logic built in, but there is a way to do it, and that would be it. So the next real big thing that we want to check is when we insert our new document, our new embedding. So I'm going to go ahead and comment it out first and then run this. And what we should see is all of the text. Notice that it does say, quite literally, texts, right? So it's printing those statements out. If I changed it and ran it again, it does not say texts because I am passing in the embedding itself. That's a way to customize it, and then also, of course, verify whether or not the customized one or the actual one is still working. So now we've got ones from the database again, so we can rerun the query again and just see that they're all, of course, identical because they're all coming from the same source. Now, you might think that this is overdoing it, like we're really just trying to solve something that we don't necessarily need to solve. But when it comes to embeddings, we might want to customize how we do our embeddings, or we might want to change them, and we might want to change them both in our Django models as well as in our Llama Index. That's the key here, is to make sure that all of that is working the way it should in terms of reusing your embeddings in different places. Now, by all means, go ahead and regenerate new embeddings if you want. But if you have a ton of data, like thousands and thousands of pieces of data, you're not going to want to regenerate the embeddings. That's going to just start to get really costly. Or if you just want to use a more robust embedding model, which I would recommend, then you would not have to redo it again. You wouldn't have to double your costs, essentially. You'd be able to reuse these things throughout, which is, I think, really, really important and the key to customizing these embeddings. Off the video, I went ahead and turned all of the notebooks from the last few parts into their own modules so we can actually run, syncing the blog posts, getting the semantic query engine, and then also even getting the top K, the top number of responses and how they're ranked. So I just want to go over that code right now just so you can see what it looks like. And really, it just comes directly from the notebooks that we've already been doing. The first thing is what we just finished was my embedding model. This is all empty by default, just so it's really easy to customize whenever we need to customize it. So that embedding model will then go into our settings for this RAG, which we've got. Here's all those default settings and that embedding model in there. And then we have this function called init, just to make sure that these things are initialized inside of the settings when we go to run anything. So when we do go to run anything, we're going to be using the engines, all of the engines that we created. Number one, we get the database URL for it, which will help us get the vector store from what we just did. And then that vector store is that Pgvector store that all comes back. Then we can do a semantic query index, which comes all from that as well, getting that vector store and the storage context to get the vector store index. The reason I call it the semantic query index is because you might have more indices than just this, which is why it's named that way. And we actually see that in just a moment in terms of the actual retriever engines. So the actual query engines themselves. The first one we see here is a retriever engine. This is new to us. We'll look at this in a second. But then we also have the default one, which is just our default semantic query engine. So this other query engine, we can actually change how many results come back in terms of the semantic similarity, that cosine difference, that distance between how close the query is to something else. This is how you actually can do that based off of the number. By default, they all come in actually as well. So we can actually see this in action with this, this notebook here. We can see that we can sync the blog docs. That sync manage comes from grabbing the query index, grabbing the docs, which does the same thing we've seen with the embeddings in there. And then it goes ahead and run through all of this. Now, one of the other things you might want to have in the docs themselves is basically say if obj.embedding is not none. Something like that, or rather, if it is none, then we would just continue along the lines. Okay, so there we go. And basically, it's going to go through and sync all of the docs, and then we can use all of the different engines as such. So this query engine, this is what we'll probably reuse a lot in the near future. With that query engine, we can get these source nodes. Those source nodes have scores in them, and you can actually see each node's score as well. So this is going back to very similar to what we did in the last one, but what we were doing before was getting the response and then printing out response.response. We saw just that, right? This now gives us a little bit more of that data that we might want for the top nodes that actually match to this. So in this case, we have these two as the top nodes. Hi there, not a great one. So how about dog jumping? Do that quick search there. And now we've got two that actually match really well, but only two. But if we actually change this to being the semantic query retriever engine, we can actually get a top number. Now, I only have 4 items in this database, so 5 just doesn't even make sense, but we can change it as we see fit. So once again, we can do dog jumping down here, and we can run these things, and we would be able to see. This is going to give us all of the rankings. So there's only 4 of them, so we only see 4 rankings. But now it gives me a little bit better of a response in terms of how many things I might want to have in here. So now we're kind of back to where we were with, doing it with just Django, with the Django search posts, basically this right here. But of course, it gives us a little bit more information than that, and also this helps set us up for the next few steps, which let's take a look at how to do that now. If you need any, information on how all this is done, please let me know. But really, I just separated things out and put them into their own modules just to make it a little bit more reusable inside of my Django project, as we'll see soon. Now we're going to take a look at how to do text to SQL with Llama Index. This is a very straightforward process, but what I wanted to point out first was the fact that we've got db.py now just to have a function, a single function to get the database URL or the database URL pool, whichever you end up using. When you actually use this in production, you'll probably use just the standard database URL. Since we're using it in Jupyter, you would use the database URL pool. That also means that we updated the engine, engines.py, to use that same database pool. And that's also stuck at pooling right now, which you could have as an environment variable for this toggle if you want, but we're going to leave it just as is. Okay, so with this in mind, into a new Jupyter notebook, we're going to go ahead and set up Django. We'll bring in the configuration variables. I'm not sure if we'll necessarily need the Python decoupled config, but we'll bring it in. Then we also have our blog post and then also different RAG settings. So I grabbed the DB module as well as the settings. All this is going to do is get our database URL, and then in settings, we're going to go ahead and initialize all of the default settings for Llama Index, as we've seen before. Then we're going to go ahead and import a bunch of things that are required to actually do this SQL querying. First off, we're going to use SQL Alchemy to create an engine, really just creating the connection between Llama Index and our Postgres database. Then we'll also inspect those tables just to make sure we are using the correct actual database that we want to query. Then we'll go ahead and take a look at our SQL database stuff, and then we'll do a first simple query, and then we'll actually get the SQL back from it. So let's go ahead and get this started. First and foremost, we're going to go ahead and create the engine itself by using create engine and grabbing this vector database URL. The RAG settings are already going, but the idea here is I want to inspect the engine here after I actually run it. Inspecting the engine should give me these database items. Those are the tables directly from the database. Now, before what I had was the vector DB in here. So I did have that on the video. So if I were to run all of those, so kernel restart and run all cells, I would get different tables going on in the database engine itself. So you want to make sure that you're using the actual Django tables, which is why I wanted to point that out to what database we are using. And we'll go ahead and restart and run all cells again. Great. So do keep in mind that if you go back into the Llama Index stuff before, the actual semantic query engine itself is going to change that. So going in here, we've got our get vector store. This actually changes the database name and table. It really just uses the username, password, host, and port of the other database. So these two really don't change a whole lot. The host is a big difference between the two of them, but generally speaking, the idea here is I shouldn't have to change anything related to the database URL for the semantic engine. Just for this one, which is why we're talking about it now. Okay, so with this in mind, I'm going to go ahead and actually iterate through some tables here. So what you can do is you can actually hard code the tables you want. Like you could grab one of these strings, or you can actually iterate through the models you're going to use. At some point, we're going to add another model into this, but for right now, I'm going to go ahead and just iterate through this, and we can see the blog post model is in there, right? So this isn't necessarily the only way to do it. You could use the hard coding of it, but if you just wanted to go based off of the model itself, you could grab the database table name just like that. So now that we have these tables, we can initialize the SQL database directly from Llama Index. This is just your wrapper for really this engine right here. It doesn't really do a whole lot other than get us prepared for actually doing queries here. One of the things it's going to say is it does not recognize vector of column embedding. This might change at some point because Pgvector and Pgvector Python is very popular. So just keep that in mind that warning might not come in. It's not really necessary. Since it doesn't know it, it's probably not going to even query it or try to do anything with it. Next up, what we're going to do is we're going to actually implement the NL SQL table query engine. The way I think this is natural language SQL table query engine. That's it. So this is the engine that we've got. Very, very straightforward in terms of how we do this. Then we can have that SQL engine do a query like what blog post has the most content. This one may or may not give us actually a response back. This might be too advanced of a question, which seems like kind of silly that it is too advanced of a question. Let's do something a little bit more simple. Which blog post is recent, right? So right now it's saying there's an issue with this query. So let's go ahead and change it to something more like what is my most recent blog post and do a response like that. Now what we should get back is, well, a response with some synthesis in here. Your most recent blog post is titled so on and so forth. So it's actually looking it up and then telling you the response right back to your question. So it's rephrasing what the response would actually be. It's not the actual SQL response, which we could go through these nodes as well and take a look at the content that comes through there. This actually gives us that data, right? It gives us the raw data in there, which if we went to the 0th element here, we should be getting, it actually gives us a string back. So that's not ideal necessarily, but we could change our question like, what is my most recent blog post ID? Not OD, oopsies, that should be ID. And then we can run all of that again. So when you're doing something like this SQL query engine, it's not to return results. It's much more returning, you can return results, but you shouldn't expect this to be a perfect response in terms of, now I'm going to go ahead and do another query on my project. It's really just, this is the data. Similar to like if you were using ChatGPT, you're not going to take that exact response and put it into your query, into your database. This is the same sort of idea, is it's going to give you those values. So the next thing is actually seeing something called the actual NL SQL retriever, or the natural language SQL retriever. So getting the actual SQL command that's coming through in here, that's just another thing that we can do. And so we just declare it like this. We pass in the SQL database wrapper, we pass in the tables we want to use, and then we want to return the raw string. So we can do something like exactly like this one. So I'll go ahead and do R now. And it's no longer query, so it's going to be the retriever. It's just simply retrieve. What is my most recent blog post ID? Go ahead and do that. And then I'll do for node in response. We'll go ahead and print out the node itself. And we see that it gives me 37. What is my least most recent blog post? Right? There we go. Fantastic. So it's definitely showing me exactly what needs to happen. And then I can also just go ahead and print out something like the R here that can show you everything that's coming through with that result. You can also print out node.metadata in here. And we can see the actual query that was done to get that result. So that is the natural language query from this. And so what it's doing, of course, is it's taking into consideration the schema itself from the blog post, right? So if I said, what's my most recent blog post, it might give me other tables in here, which is what's happening here. So it's got ID, title, and timestamp from this blog post, and it orders it by the timestamp, and then it only gets one, right? So least most recent would be whatever this one is, 29. And of course, we could verify this by going into our project here. So 127001 into the admin, assuming it's still running, into our blog posts in here. And then the oldest one is likely going to be the smallest ID. In this case, it's 29. We go back in here, 29. Fantastic. So now we just need to combine these two things. We need to combine text to SQL with our actual semantic search, so that we can have a little bit more robust responses here if we need to. Like, what is the summary of my most recent blog post, for example? So that is something that is a little bit more powerful than what we've got here. But before we get there, I actually want to generate a bunch of fake views. So I'm going to go ahead and create another notebook that will actually have fake views, so we can kind of see what page views might be like for any given blog post, as in two models that are actually related to each other, and see how this querying ends up working there. Now we want to see how text to SQL works across multiple tables or multiple Django models. The way we're going to do this is by creating an analytics app. So let's go ahead and do that first inside of our Django project, Python manage.py, and then we'll start app and analytics. Okay, and then in here, we're going to go ahead and just create page view, and it's going to be models.model, and we're going to go ahead and give the foreign key in here. So I'm going to go ahead and do blog equals to models.foreign key, and this is going to be blog post. Let's actually change that to being just simply post, and then we'll go ahead and do on delete equals to models.cascade, and then I'll go ahead and do from blog.models. We're going to go ahead and import the post here, or rather blog post here. And then I'll go ahead and do a timestamp in here as well. Timestamp, models.date, time field, auto, now, add being true. Okay, so I actually do not need a count or anything like that. I could probably track the IP address as well, but the idea is we're just going to create a bunch of these instances, and we're going to do it inside of a Jupyter notebook. So inside of our settings, again, we'll go ahead and add in the analytics here. And then I'll go ahead and run my migration. So Python and manage.py make migrations. And let's go ahead and migrate it. Great. So back into Jupyter here, we're going to go ahead and create a new notebook, and it's just going to be creating page views. So we're going to go ahead and do 14, creating page views for blog posts. Is it 14? It might be more than that. It is 15. Okay, cool. So let's change it to 15. All right. So import setup, and then setup.init Django. We're going to import random. We're going to go ahead and do from the blog.models, import the blog post, and then from analytics.models, import page view. Okay, so what we want here is we're going to go ahead and grab our query set, which is going to be our blog posts .objects.filter can delete being true, and then I'll go ahead and do for object in QS. Now I'm going to go ahead and say random views equals to random.randint, and it's going to be, let's say, between 500 and 2500. Quite a bit different. And so then I'll go ahead and actually create a new post for each one. And so there's like a couple of ways on how I could do this more efficiently, but I'm just going to go ahead and do for I in range, or let's go ahead and say for X in range, because it's not an index value, it's just a number of that value, whatever it ends up being. Then I'm going to go ahead and do pageview.objects.create, and we'll go ahead and do the actual blog post. What did we call it? We call it post equals to the object. Okay. And so now it's going to give me a list of all of these items. Granted, if you have a lot of items, this would take a really long time, but I only have 4 items, so it's not going to take a long time. Again, it's just meant to simulate things, and this could probably be done a lot more efficiently somewhere else. I'm not really worried about the efficiency at this point. I'm really just worried about getting those analytics in there. So we'll go ahead and bring it in with from models, import the page view, and then admin.site.register page view. Save that. That's still running. But if I were to go into my page views here, I should start getting a bunch of different page views based off of the various objects. Now, there's definitely ways to make this better data, like better fake data, for sure. If you look into a package called Faker, that could actually fake IP addresses, it can fake usernames and all sorts of stuff like that. That might be something you'd actually rather do than what I just did here. And then also, we should probably use objects.bulk create. That probably would have been a little bit better than what I'm doing here, because it's going to take a little bit of time. And of course, it is definitely going into our tables, into our analytics here. So if we look inside of our Neon console and go to analytic page views, there we go. So it's actually creating all these different page views in here as well. And of course, it's going to be a lot of them. All right, so all of those page views were created. There's 4,000, a little over than that, for all of the blog posts that we designated. So let's go ahead and actually do our text to SQL across multiple models. Now, what's important about these models is they are related, right? So there is a foreign key relation to them. So there's a direct correlation to how we can talk to these things. So that isn't always going to be the case, but in our case, it definitely is. So I'm going to go ahead and duplicate my text to SQL with Llama Index 1. And now we're going to go ahead and open this up, and we'll call this 16. And now we'll do multiple models text to SQL with Llama Index, just like that. Now, the process is surprisingly very easy, or maybe not surprisingly. So all we need to do is bring in our model. So this is our page view model here. We import that. We create the engine. We can still inspect it. We can see that our analytics model should be in here somewhere. There it is, page view. Inside of our models now, I can actually bring in the page view model, and that's what's going to be in our tables now. We initialize the SQL database, inside of Llama Index, we initialize the engine. Now, instead of what's my most recent blog post, we can now say what blog post has the most views, and run that. And what we will get, of course, will be the answer. So if I actually just print this out as a string here, we will see the response with the actual inferred response that the text to SQL is doing and the LLM is helping us with. So for some reason, we get this weird error every once in a while. I'm not sure why, because sometimes it works, sometimes it doesn't. But there we go. We've got this blog post with most views is blog post 1, right? With a total of 1,500 views. Fantastic. How about my least most viewed blog post along with the actual SQL command that's coming through there? This, of course, will give us what that SQL command would end up being, which is this right here. Pretty good one. And then it gives us the new blog post with 0. So that's the result right there. Now, of course, there's 0 because if we look at that blog post of ID of 29, let's go ahead and take a look. ID of 29, we see that it is, well, cannot delete. So it actually isn't respecting that as argument here. So one of the things you could do from that is you could actually have it where you use a different prompt. So in the prompt itself, when you do the querying, you could change that prompt. That's outside the scope of what I want to do here. What I want to do now is I actually want to start moving towards using not only these multiple tables, but also actually having our semantic search as well. Something like which blog post talks about dogs has the most views. That's kind of a weird question to ask, but it definitely could happen with this current environment and this current setup. So let's go ahead and take a look at how we do that now. Off the video, I went ahead and took this notebook and I turned it into, well, a few functions in the RAG module that we created. The first function is getting the SQL engine tables. These are, of course, these two tables here. The reason I'm using apps.getModel is so that if I ever need to actually use this in a models file, I can. I don't have to worry about it then. But of course, this is just getting the table names themselves. So you don't even need to do it this way. You could hard code those table names as we've discussed. Next, of course, we created a function for getting the SQL database itself, which of course gets the database URL. Of course, it's the Django database. It's not the Llama Index vector database like we did before, which of course is written out up here with all of those parameters. Next up, of course, we actually return back that SQL database so we can reuse it wherever we need to with SQL Alchemy as like sort of a wrapper. Of course, now we have the SQL query engine, which gives us the exact same, natural language SQL table query engine that we've seen before, and then also the retriever if we ever need that one. And that's pretty much it. Settings.py didn't actually change. I just got rid of some comments, but overall, that's where we're starting this one off. And then I went ahead and created a new notebook that's really going to explore customizing our prompts. So the reason we might want to customize our prompts is something that I've seen a couple of times with the SQL query engine, mostly because of how that prompt ends up working. So what we want to do is we want to actually take a look at the prompts for our two engines, our semantic query engine and our SQL query engine. So the way we do this is I'm going to go ahead and just look at the default response synthesis prompt. So what happens with the SQL query engine is we actually can, basically summarize what comes back with that SQL query. And this is that summary. So we get the input query, whatever that might be. So like our question of, what are the most popular blog posts of this last week? That's the query itself. That gets converted into a SQL query, which is a proper structured query language query, right? Or at least in theory it would be. That is, of course, going to be based off of the actual LLM we end up using. So the LLM is going to generate that query for us in combination with the prompt we're going to look at in just a moment. And then, of course, after that, we've got the response from that query. And then the response synthesis prompt will take all of that information, send it back to the LLM, and then give us an actual response of some kind. Great. So then we also have something for the text to SQL prompt. This is the default one. So given an input and a question, create a syntactically correct dialect as in a SQL query to run, and so on and so forth, right? And so in my case, I actually wanted to make sure that it's a precise SQL Postgres query to answer. So I actually wanted to customize just that and then a few other things about it. Now, the idea here is I actually made this prompt with Claude. It's an LLM much like ChatGPT, but the idea is you want to potentially customize these over time to make sure that they are working well with the things that you're passing in. You also might want to actually add in your own schema. You maybe don't want to actually use the schema values that are inside of these tables, right? So perhaps you kind of refine them to only use certain columns that are in there. And you could limit that in the actual custom SQL prompt itself. And so this is actually what we want to customize. Now, before I go any further, you might be wondering like, well, how do I know how to get all of this information? And how did I know how to find this? The way I did it was by going into the actual class itself. So either class or any of the classes, I went ahead and went to the definition of these classes directly in their code, and I went through each argument for actually configuring them. Here's that text to SQL prompt. Notice that it's using a base prompt template. Here's that response synthesis prompt and even a refined synthesis prompt. So there's a bunch of different prompts that are coming through in here that gives us the opportunity to change it. The text to SQL one makes a lot of sense. It's your actual query that gets turned into SQL. So that's the one that I actually went and looked for, which is exactly what we've got here. We've got the SQL retriever. You could use either one. But the idea being we want to grab what those prompts end up are, what they end up being, and then we define our own. And defining your own, you could actually take a look inside of the Llama Index prompt so you can customize all sorts of things in here. But of course, they have a lot of stuff that just works out of the gates. So you're going to want to experiment with this on your own if you ever need to change the prompts. I think the SQL prompt could be improved even in here going forward altogether. And then the response synthesis, I don't know if we need to customize this a whole lot, especially because of the LLMs are getting a lot better over time anyway. So we might not need to customize these prompts a whole lot, but knowing how to do it is actually really key here. And so what I did was I have this, get SQL query engine, the actual function inside of our own RAG modules. We have our prompts that we can pass in here, and we can see SQL only, and we can also tell it to not synthesize the response in there as well. So if we change it to false, that will allow us to actually see the SQL that's coming through based off of the SQL prompt. And so let's actually take a look at that. If I were to run this in here, it goes through the query here, and now it just gives me the actual SQL. So this will give you some time to actually play around with it. If you're getting errors with your SQL, this is where you can actually see the actual SQL that's going through, and that's when you can start to refine your prompts over and over and over again to make sure that they're correct, right? So if you end up using a different database, so it's not Postgres, oops, that's a typo there, but if it's not Postgres, if you use something different, feel free to change the prompt as you see fit. And overall, what that prompt would end up doing eventually is you'll end up seeing a different SQL query that's coming through in here, which is actually kind of cool that you have the ability to do all of these things. And so now that we've got that, we can actually just synthesize the response here. We'll change SQL only to being false. And then now we can run this and we can see what the actual response would end up being for this SQL query engine. And so this is really, really cool. So what it says right now, there are no blog posts with views recorded for today. Of course it's not. I actually didn't create it. I didn't run it today. That was yesterday when I recorded it. But the idea is if I wanted to create those views, let's go ahead and do that. We've got this 15 create page views here. And I'm going to create a bunch of page views in here. And right away, I should be able to now get a response of some kind from the query because it should be already creating views in there. And there we go. So now we've got one with 159 views. So it's actually really, really effective. And the SQL query engine might be the only thing that you actually start implementing in all of this. Granted, we could actually build one of these things out ourselves as well, much like what we did with our own semantic search. But Llama Index makes it just a little bit easier because then you can start chaining it together with other features like what we want to do right now. I did mention that I probably won't cover the prompts, but I realize prompts themselves are something that you're going to want to continue to refine over time. And there's a whole job called prompt engineering that you might even want to refine even more so than this. The other thing is once you start chaining these things together, then maybe you cache some of the results from some of the queries, and then you actually inject those into some of the SQL query engine stuff itself too. That's quite a bit more advanced than what you probably need to do anytime soon. So now what we want to see is actually just bringing together our semantic search with the SQL query engine to see how those things actually play out, because they really do work in tandem pretty well, or at least they can. All right, so I actually did a bunch of things off the video so we can have more realistic data. Now, the things I did, I'm going to go over right now, but of course, you could always go to the repo, grab these commands, and just run them. The first thing is having more realistic blog data. So I actually created this management command to load in a CSV file. That CSV file has a bunch of different columns in it, but the ones that we wanted were the publication date, the title, and content plane. This data itself is coming from Kaggle. So if you go into Kaggle and do a quick search for Seth Godin's blog dataset, you'll be able to find this dataset. You can download it. It's just a CSV file that you'll move over, and you'll have all of this data. So where we move it over is going to be written inside of the load posts management command in here, and that is with open this right here. So it's in the repo dir, which is base directory one level up, into datasets / Seth-data.csv, which I don't think I changed the name at all. I think I just loaded it in, but here's that data set, and you can open it up and you can see here's all the different columns in there with the CSV and also the index column. But the idea is we just want the title and content plane pretty much. I also get the publication date just so I can see exactly when it was done, but that part's not even necessary either. The way we get the date is from pip install date parser. And then you just run this and it'll load everything in. And so the way you run it is by just running, python manage.py load posts, and that will load all of those dataset posts in there. Now there's something to be important about this and something to be careful about, and that is the actual posts you load in. In my case, I only did 50. The reason I did 50 was because I don't actually want to do embeddings for this entire dataset. So remember back to our model for our blog post, this will actually create the embeddings for you. So if you do more than 50, it's going to create a lot of embeddings. So you could even do 5 if you wanted to. Just make sure that when you go into this load post command, you change the number of rows that you want on here, the maximum number of rows, like 5, for example. So yeah, that's something you'll want to do when you actually load this data in. After you load the data in, you're going to want to create fake traffic, just like we did in the notebook a few times ago. The idea here is we actually do a query set, and then we create fake traffic based off of this management command, which has minimum and maximum. Which with minimum and maximum, what you can do is just say something like fake traffic, and then min being like 1, and then max being like, 5. And then that will create only a small amount of traffic for each blog post. In this case, it's 152. But keep in mind that there's 50 new blog posts in there, so that's a lot of traffic considering. But overall, that's the idea here with those two, with the actual blog posts, to give some traffic in there and also to give us better, more realistic data in our blog. Also with that, I actually updated the blog admin, so I have my titles in here so that I can actually just do a quick search for any given title, like thoughts on board, something like that. Oh, let's make sure our server's running again. So you can actually go into it and do a search specifically for titles. The reason for this is really just to validate our RAG pipeline here soon, which we definitely will do. Now, once you have all of this data, what you need to do is you need to update your blog dataset. So this is actually something we'll come back to in just a little bit. So feel free to drop this one now, because in the notebook, we will make sure that those things are all in there and make sure that we can actually run everything with that notebook. Now, you will also notice that I did make a bunch of different updates to the RAG commands and modules. We'll come back to that very, very soon. The important part of this part was just to make sure that we have the dataset, that Seth Godin dataset, so the next part just makes a lot more sense. It's not that gibberish that we had before. So be sure to delete all of your old blog posts if you didn't do that already prior to loading these things in. But if you did all of that and you're ready to go, let's take a look at the next part. Do keep in mind that even if you did use the gibberish stuff, you'd probably be okay, even if you didn't do this step. I just wanted to show you this so it's a little bit more practical overall. And again, all of this code is on the repo. If there's anything confusing about this, if this is like too advanced for you, please let me know in the comments and I'll try and help you out with where you can learn more about how to do all of those things. Let's take a look at the final lesson. It's finally time to actually talk to Django. Now, there's a little bug that I found in Llama Index that may or may not be solved by the time you're working through this. So do keep in mind that there is some customization here that actually allows this to work, although I do think that it will be fixed in future versions of Llama Index. And just like we said before, Llama Index is most likely going to change. The idea behind what we're going to do here is we're going to take our semantic search through Llama Index and our natural language SQL search through Llama Index to get our final result. We're going to combine those two things so we can ask a little bit more robust of questions. And so to do this, we have a few different imports we need to go through and just to make sure that everything's up to date. Now, what I've got here is a new one that you haven't seen yet, which is the RagDB init vector database. And so what we've got here, if we actually take a look at it into our db.py, we've got this init vector database one, which actually goes through something you've already done. This actually creates that database all over again. Now, if you actually follow along with me in the last part, you notice that I did delete that vector database. And so this command will recreate it just to make sure that it's in there. And then after it is created, we actually want to update all of those index documents with our saved embeddings. In my case, all of my blog posts do have saved embeddings. They actually were recreated when I entered them into, the actual database. Now, if you didn't do that, keep in mind that it might not work. But anyways, so now I'm going to go ahead and run that, make sure that all of my documents are inside of my database. This is all the Llama Index, vector database stuff that we wanted to add in. And of course, once I refresh in here, they'll all start to be added in there. The new embeddings should not be being created. It shouldn't need to create new ones because they were already stored in the database when we created the new ones, when we entered that data in. Okay, so hopefully all of that stuff is just sort of review, but now they're all in their own modules, so it's a lot easier to just run them, and then of course you can always unpack them later. So the next few things are fairly straightforward as well. We get our vector index, we get our semantic query retriever this time. So the retriever engine instead of just the query engine, and then of course we get our SQL query engine in here as well. And then I added a couple things to the settings for VectorDB and blog posts, which is why you see it as is. They just changed the location just slightly if you want to unpack a little bit more. Okay, so the thing that we want to do is we want to use the vector tool, the query engine tool from defaults using our semantic query retriever. Again, we already built that. That is straightforward on how it ends up working. This query engine tool, if we combine it with the SQL tool, what we end up getting is both of these things being queried in sort of tandem together. We'll look at that in just a moment. But the idea behind this is that we want to actually have the ability to search both query engines. In this case, we actually use the query retriever. So this is actually where the bug ends up happening, or that I found with Llama Index. The semantic query retriever that we have, by default, it doesn't actually work with their SQL auto vector query engine. Now, this is in their blog post, so if you actually went through it, you would have some issues with it. And so I actually created a way that makes it really simple for you to use it. But the idea being, we grab our query engine tool, we make our vector tool, and then we make our SQL tool. We want to combine those things. I'll come back to the bug in just a moment. Then we actually use the SQL auto vector query engine. This actually combines both of those things together. Now, we already have all of the defaults, like the LLM that we're going to use, the embedding we're going to use. All of that comes from our RAG settings that we set a long time ago. But of course, that's a module that needs to be run in order for that engine to work correctly. So going back to our settings.py, this init method, those are what's happening. That's the actual context that's happening for the eventual SQL auto vector tool. So what I want to show you is the actual error working first, so then you can kind of identify it yourself. So if I ran this right now, what I get right off the bat is that we need it to be a vector index auto retriever, which is probably still true. It's probably going to be true in the future. But with my tests and everything, it just kept on running errors with some sort of pedantic error. It didn't make a whole lot of sense. So after spending some time reverse engineering this SQL vector query engine, I actually went ahead and just removed that as being a requirement from when it's being initialized, this vector index auto retriever class. Now, the reason I tested this out is because our semantic query retriever was already working. It was already working really well. I can't say for sure this would work in other databases or other contexts, but I do know that it works really well for what I did. I did a bunch of tests on this. So that's really the only thing that I changed. I just removed this value checking, whether or not it was the instance of that same class. And then I now have my own, my SQL auto vector query engine class that's in here. And this is all you really need to do is import these few things, and then you could copy and paste. This is basically exactly that same class, just with this one part commented out. And so I would imagine at some point this will be changed or fixed. So feel free to test out the original one. But here we go. We now have this query engine here. And so I don't have any value errors anymore. I can now attempt the process of doing these next requests. So the very first request is what kind of org is discussed. Now, if I actually looked at the blog post I can do a quick search in here for org. Let's go ahead and make sure our server is running again. And here we go. So into src, python manage.py, run server, and back into our project, we do a quick search for org. The reason I actually have this query is because I have a title called what kind of org, and then reality of organizing as a principle or whatever. But the idea being I actually did that search on the blogs directly, which is why I have this response of what kind of org is in there, right? And so that's what we want to work off of, not from this blog one, but here we go. So we go ahead and run this, what kind of org is being discussed. Now, what it says is it's querying the other engine. Notice it says nothing about SQL itself. Nothing about this query is like, hey, what's going on in the database? So if we look at the response itself, it gives me a response that sort of summarizes those blog posts, I think, to some degree. Obviously, we could do some more analysis on that. That's not really the point. The point here is the next one has a lot more implications of both of those things involved. We could actually probably do this on our standard, semantic query engine or a query retriever. We could probably do something like that would give us some sort of answers very similar to this in some sense. But what's happening, of course, with Llama Index is it's actually allowing some synthesis going on with the question, the actual search, and then interpreting what's going on there. And so our next query is going to use both things, which actually makes a lot of sense, because if you say what are the top 5 most used blog posts, that right there should go, oh, this is most likely a database query for factual data. This is structured data that's stored in Postgres already based off of the structure, of course, of all of our blog posts, but also the foreign key to all of those page views for all of those blog posts. In my case, I have 80,000 page views. Of course, that's not realistic in terms of the real data because it's all fake data. But overall, this query right here, the LLM is smart enough to know, hey, this is a SQL query, so let's make sure that we use that SQL tool, the actual SQL engine itself, the SQL query engine, which is what's happening with that tool. And so once it does that, then it's going to go, okay, what kind of keywords from their content? Let's go ahead and extract those keywords in there, and that's exactly what's going to happen with this response here. Of course, it is still calling the LLM that we defined in our settings, which just, again, going back into them to look at what that is, the LLM itself is going to be GPT-4o. If you want better results here, you just use a more powerful LLM. This is not about the embeddings. Obviously, using more powerful embeddings will help with the semantic search. This is not about that, but this is doing both sort of things there. It's actually querying everything. It gets all of this stuff, and then it grabs the content keywords. It actually makes those keywords from all of that content, and there we go, from the top ones. We could also just modify this a little bit and take a look at, let's just look at one of the blog post dates, for example. I'm going to come in here, and I actually don't have the dates showing up, so let's go ahead and bring those dates in to our admin with a read-only field for the timestamp. Save that. We'll refresh in here. And the only reason I'm using dates is so that I can actually test out what's going on. So we'll go ahead and say April of 2022. So what were the top blog posts from April of 2022? So I'm going to go ahead and copy this and say, what are the top 5 most viewed blog posts from April 2022 or 2020 rather. And yeah, that's going to be our response. And then we'll go ahead and print out the response.response. We run this. And of course, what we'll end up seeing is it's going to do a query into April of 2022. This right here, to me, is very powerful. Look at the SQL query that we've got. This, I think, is very accurate in terms of the SQL query. And then we see that we've got no blog posts for this data available. So, perhaps the page views is actually the problem, which is really interesting. So the actual blog post isn't the problem, the analytics page view, which actually makes a lot of sense. So let's go ahead and say, instead of from that, we'll go ahead and say from, let's say today, which actually will be all of our data, right? So it's going to be the same data most likely. But the point of this is, in the future, once you actually have blog posts and you have some data that's coming through, this is going to be a lot more accurate to what's actually happening with your actual data, right? And there we go. So this is just logging all that data out. Here's all the actual response. And of course, you can use Markdown, which is built into Jupyter Notebooks. You can display that response as Markdown, so it's a little bit better of format. But there you go. It now has that. What if we did the least viewed blog posts from today? You could do all that as well and see what the least viewed is. And of course, what we will end up with is these right here. Great. So yeah, I think it's actually really powerful, and this is a really simple-ish way to go from text to SQL and really make all of this work. Now, I think the big challenge here would be to turn all of everything that we're doing here into your own queries themselves, like not using Llama Index and seeing how that works. I think Llama Index has a lot of really strong, attributes to it, but every once in a while you'll find these weird bugs that are happening that are just hard to get around, like I saw in this one for the SQL Auto Vector Query Engine, which I think is why it would be a good challenge to undertake, trying to do all of this talk to Django stuff in your own queries and building it out yourself. That is not a trivial task. I've tried it, but it is something that I think would be really interesting to see. Even if you don't do that, this right here, to me, is so cool. Now, granted, this isn't about making like a new chart or graph or something for your actual web application. It's much more about letting your users do a quick search on there and getting responses back that are like this. That's what it's all about. It's not about restructuring your application to work around these kinds of queries, at least not yet. Maybe at some point we will have very robust and reliable queries that return things back in a format that makes a lot of sense, like a JSON format. But the thing is, these queries can be rather vague, right? So like content keywords, well, what if they said just most often words, most frequently used words, or something like that? Those kinds of queries don't really lend themselves well for then displaying it on a web page in terms of a chart and graphs and all that. However, what you could do is you could start to analyze what these queries are that people are asking and be like, oh, this one is incredibly common for a SQL query, so I need to put that somewhere. I need to make sure that it's on my site so it's really easy to access for my end users or for myself if I'm trying to analyze what content I need to create next. So yeah, I think Talk to Django, this is actually really, really cool, something I want to see a lot more of, and I plan to do a lot more of in my projects. Hopefully you do as well. Hey, thanks so much for watching. Hopefully you got a lot out of this, and thanks again to Neon to helping bring this course to life. The idea that I got from this one is really how important our own data and our own data sets can be in discovering what we could do next with that data. Like our blog posts. What are my most popular blog posts from this last year? That question alone, yes, there's a lot of different ways on how you can figure that out, but then asking follow-up questions, that's super interesting, and it might actually make for compelling content for now into the future as to what you could do. And that's what I think the promise of semantic search really gives us, is we can actually just use natural language so we can start talking to our data in a way that was just previously not that accessible. Even if you knew SQL, would you be asking these kinds of questions? Maybe, maybe not. But the other thing is, now we can actually start enriching our data even more. We could say, what was the weather like for the vast majority of my users on this date? This date happened to be the date that Well, maybe one of my most popular products was sold. These types of questions that don't normally, collide with normal analytics starts to happen with these LLMs, and that's why I'm so excited about it. Now, I think the tooling is still being figured out. There's still a lot of things about the tooling that will start to emerge in terms of how we can actually do like natural language SQL queries or semantic search. Although those things, as they start to get better and better and more stable, we will start to see even better ways of how to implement them and use them. And of course, I want to cover them. So of course, that last challenge that I mentioned before was how do you actually take the things that we did with Llama Index and how do you do that more manually? How do you do that with something like Numpy or maybe some more low-level tools in Python? I think that would be a really interesting challenge to undertake. Now, granted, we already did the semantic search of it all pretty low level. There's not really a whole lot lower you could go in terms of using Python. So do keep that in mind when you go forward. So thanks again for watching, and I look forward to seeing you next time.